if it's the commerce, if it's commercial place, then obviously that will be means open only during daytime, let's say from 9 a.m. to 5 p.m. So demand will be only during that period, and the demand will be very less only for drinking and drinking purposes mostly, and for washroom purpose. So demand will be very less, and it will be more or less uniform demand. So you can basically create a different flow pattern for this. We also discussed about how to use field calculator to to find the attribute or to fill the attribute of a particular selected layer yeah, using some formula, or you can give direct value to a particular field using this field calculator. So we discussed about this yesterday. Then regarding pipe, we discussed about diameter and the roughness value. So for the roughness value, we have given this. We have selected, I think, Hazen-Williams formula, and you can give for cast iron, it is something around 60 to 130. So you can give, depending on the age of the pipe, normally we give the range of this roughness value. Then then we discussed about tank. Tank, we have considered. In tank, we have two type of tank. One is variable tank, and another is constant reservoir. So that means if you are selecting a constant reservoir, our only consideration that we need to take into account is how much height is from the base elevation, that is the ground elevation. So ground elevation, if it is 82 meter, that was the case we took yesterday. And in 82 meter, if let's say, if the constant height, if we can give a constant height of, let's say, 15 meter. So if it is 82 meter, then the fixed SGL will be 97 meter. So we started with this example. I hope everyone has done till this point. Everyone, your junction, pipes, and tank, everyone can see this green tick here on,
Yes,
on
sir.
your system?
Yes, sir.
Yes,
Okay.
sir.
So here, once you have done this, so this is the simplest form of network that we created yesterday. What we will do today is, this will be our base. Your model is ready. So we will, yes.
Sir, we are taking tank in constant reservoir.
Yes, in first example, then we will take other example also. Okay, so now today your base model is ready. You can do n number of changes, and you can run your simulation and see the analysis quickly. So today we will like doing 20, maybe 15 or 20 type of simulations today. Okay, and we will be considering all changes that we are making here. Okay. Hello.
Yes, sir.
Yes, sir. Okay.
Yeah. So your base model is ready. We will also introduce pump to the same tank, same system. We can introduce valve in the same system, and we can apply zoning in the same system. So we will do all these exercises. All these exercises will be very quickly done if your base model is correctly made. So okay. So once you have done this, what you need to do is you need to create a simulation specification. Means you need to run your simulation. And to run your simulation, we have already discussed it yesterday also. I will explain it again. You need to go to this simulation specification. Once you go to this simulation specification, this plus, if you click, you will get hydrodynamic simulation and batch simulation option. So let's first discuss about hydrodynamic simulation. Let me delete all this so that we all are on the same page. Okay, so what you need to do is you need to click on insert. Once you will click on insert, you will get here option to give the details of hydrodynamic simulation. So obviously scenario ID is it will remain base, and then you need to select from here. First is steady state simulation. When I say steady state simulation, that means the flow in pipe is uniform, is constant. So that means it works on the average the flow requirement. It does not consider the daily variation or pattern flow. So first we will do with steady state simulation, and then when we are doing this steady state simulation, we need to give the SD parameter. Now, if we have already, I think on day one or I think on day one, we discussed about time step. I have shown you with example, what should be the time step depends on what is the size of your DX. I hope everybody remembers that. Hello.
Yes, sir.
Yeah. So but in steady state simulation, that doesn't matter time step, because it's a we are talking about, you know, a constant flow in the pipe. So then it doesn't it does not matter what value I am giving. This is stability criteria that we take here of, but right now in steady state simulation we are not concerned about this as well. So only thing that I need to check is in the pipe what is the roughness value that I have given, and I have here it's by default selected Hazen-Williams formula. So let's let me give the middle range value, and let's say 110 I am giving something for this pipe, and 110 is check here. If you have doubt, it's Hazen-Williams formula. So if I am selecting Hazen-Williams formula here, so it should be here also Hazen-Williams formula. Then in the output, what you need to do is, here it's saying use default folder and file name. That means if you will select this option, that means the folder where you are where you have this SQLite and MEPP file, it will be a result folder will be created in the same folder with the default name, and result file will also have default name. If you want to change the folder name or folder location, you need to select this and then give the folder location. And if you also want to change the file name, the result file name, then you can give it a separate any folder of your choice and any result name which you want. .res is the extension. So run one, anything, and anywhere you can give that's the choice. So here you will be giving also the file name and the folder path. If you are selecting this, then only you need to select the folder path. You will not be able to give the result name. Result name file name will be default. So it's simple. So let's so that we are all are on the same page. We will select default folder and file name. Again, reporting frequency, reporting start time, nothing matters in this case, because it's a constant flow into the system. So it will be one time step value only. So we don't need to change anything. Everyone has done till this point.
Yes, sir.
So,
Yes.
so,
Yes, sir.
so that means our model is ready. What I need to do is just, if you will go to the simulation, here also you will see in hydrodynamic simulation, this page also, you have this run button. You can run from here also, and you can click on this simulation and you can run from here also. So please run your simulation, everyone. See, when I run this simulation, I don't know whether you have seen here, it says exporting to .inp file. That means then whenever you will run your simulation, you see .inp file, EPANET file. And this is the EPANET file. You can use this EPANET file to export this model to any other EPANET based platform if it allows, or the same EPANET file if you have from another model, another software, you can import it directly here. I will also show you one example where I have EPANET file from some other platform, and it's one click, very simple import facility. So at the end, we started in the start only. I have told you that all simulation, all log file will be, you can see from here, and you see it says hydraulic engine activated, computing hydraulics, because there is no time step required here. So all simulation analysis completed, run simulation successfully. Everyone is getting this message.
Yes,
No,
sir.
sir.
I hear no, someone said.
Yes, sir. I am getting run simulation failed error.
Okay, so can you share your screen?
Yes, sir.
Okay, so it says cannot solve hydraulics, all simulation analysis completed. Hydraulic results available, but system may be hydraulically unstable. That means what it's saying is the design that you have done is hydraulically unstable or unstable. So let me give. Okay, so if I go to, let me check. First, let me check your network. Okay, so this is your network, and then let me check. Okay. you have elevation somewhere minus 0.6, somewhere -1, -1. So you understand this, you need to understand this. See, if you will see the log file, what it says your model is simulating, but it cannot solve hydraulics. If your system is correctly designed, then hydraulics will be solved. Means it will give you the correct simulation. So it has run it, but since it's not correctly defined, so it's saying thus your system is unstable. So you need to correct your model. You need to correct the details that you have given, and I can see many places. I don't know why you have this. Maybe when you apply this formula, you have introduced this junctions later. I don't know, and because you don't have surface elevation value also here. So when you introduce, like when you, what happens is, I can understand the problem. What happens is, like say, starting you have extracted a junction point. Okay, so I will go to this WD network. I will show you why you have got this error. And then what you do is you create a network. Then second step is you extract the elevation values of this network. Okay, so you have this elevation values. Then what you do is you create pipe network. And during pipe network, instead of connecting from here, what you do is you create a new node here. So a new node is created here, but this node does not have elevation value. And in that case, when you apply this network editor, topology repair, what it will do? It will delete this node and not this node. So the node with your elevation value is deleted and node without elevation value is available here. Am I making sense?
Yes, sir.
And that's why you have new nodes introduced in your system, and that does not have this elevation value. And since I think you have applied formula that -1, so 0 means -1, and some of the value it's automatically it will be interpolated. Like say I have here 55, and let's say let take one example. Let me delete this node. Fine. Junction. Okay, and let me show you one example. See, this is 71 and this is 75. If I will introduce a junction here, let's say here, it's saying you are creating a node at mid of another link. Would you like to split the link at the node? Yes. So a node has been created here. Now select this node and just first unselect all. Now select this node and then go to your junction and say so selected. You see elevation is automatically taken 72.488. It's based on this elevation and this elevation, because there is already a pipe has a slope connecting from here to here. if I will click any midpoint, I will divide into two parts. A slope will be means elevation will be interpolated, and that's why some of this pipe you don't have surface elevation, but you have elevation value. Is this clear?
Yes, sir.
So what in this case, what I need to do is I simply need to go to this interpolation and assignment. I think you already have a, DM, I hope here. Z assignment method from raster grid cell and then run. So if I go to junction, now I have all the elevation value. It will be Z -1. So you do it yourself, then you will have more idea. I hope you have got the idea, right?
Yes, sir. No.
Yeah. So please unshare. Anyone else have any problem in getting the simulation?
Yes, sir.
Please share your screen.
Yes, sir.
See, why I'm seeing all the screen and trying to explain, because there are many things which cannot be explained while giving the training. Only when you get the query, then means it can be explained. Okay. So again, the same error is there. Can you go to this
Yes,
junction?
sir.
You also just go to the junction point. Yes. And go to this geometry. You can close this because you know anytime you can open and you can close it. So just close the simulation window. Yes.
Yes, sir. Geometry.
And can you click on elevation? Here. In the tabular. Yeah. Yes, and then okay, so it's fine, and then you have okay, that doesn't matter if you are not given any demand coefficient. Okay, and then okay, then can you go to the pipe?
I think Mr. Manish got disconnected. Sir,
Hello.
hello.
Yes.
Hello.
See, Mani, any problem? Can you hear me?
Yes, sir. Yes, sir. Yes, sir.
See, Pushkar, here the formula that is selected is Hazen-Williams formula, and the roughness
sir.
that you have given is 0.013.
Yes, sir.
So 0.013 is the roughness for when you select Manning formula,
Manning's formula. Yes, sir.
right? So
Yes, sir.
can you yes, change the value? Means the range is we have given I think 110. So just yeah, use field calculator and give the value 110 if you are using Hazen-Williams formula. Please do it, and you can unshare, and then still have problem, then you can let me know. Anyone else
Okay,
have
sir.
any problem?
Sir, after correcting this problem, I am also getting the same error.
Okay, so we will have to check. So let me do one thing. First, let me explain the result file to everyone, and then we will do a breakout session, and then me and myself and Mani will have a quick look on all the screen. Okay.
Okay.
Okay. So let me share my screen. Okay, so okay, so you can see this run the simulation has run successfully, and nothing, no more information that I have given is the same model that we used, means we created yesterday along with you. So this is the minimum model. Now, as soon as I have run the simulation, you can go to this result view, and you see a result has been uploaded here. Can everyone see the result uploaded
sir.
here? Okay.
Yes, sir.
Yeah. And then you go to this layers and symbol view. You will find a layer and symbol also uploaded here. Can everyone see?
Yes, sir.
Yes, sir.
Yeah. So I will go to this map view. And in the layer and symbol view, what is happening is, because you already have a water distribution network here, so the layers of the water distribution network is at the background, because this layer, result layer, is on the top, is the first layer. So it is on the top. So you can see a different color, some different colors for different pipe is showing here. Even though I have given, if I remove this, untick this, I mean, so you see all pipe has same color, everyone.
Yes, sir.
But
Yes, sir.
when I tick this, you see different color of pipe is there, because now it's showing the result file, and the color is the if you have problem in identifying the color, what you can do is you can untick this WD. So now it's the result color, and in the result, what type of result is this? Remember, we have run a steady state simulation. So that's, there will be one pressure value, one flow value. So one value, it will be a single time step value. So if I go to this junction has water demand, head, pressure, and water quality. So let's go with head. So what do you expect with the head? Head will be the total head at the pipe. And what will be the head here? That should be 97 meter, because 82 plus 15 I have given. So that 97 meter becomes the head. Am I clear?
Yes.
Yes.
Yes, sir.
So just try to understand this. Let's say this is your ground level, and this is your pipe level. And whatever the, let's say, I have a head here, or some tank or whatever, I have a head here. So this is my head. I have my another pipe here, and depending on the pipe dia, through this water reaches this point, how much hydraulic head loss is here, it will have a certain head here. So your head will be whatever the means, it depends on your the hydraulic condition of your pipe. It will get a line here, and that will be your head line. So this is your head. If I want to see the value, what I will do here is I will click this head, and then I will go to level. I will say visible. Same exercise. I don't want to see in 3 decimal, and I want to see all value. Let's say you can do the offset to I mean, see if overlapping is there. If you are also seeing the WD network, let's say, and say apply to map. And now it's overlapping. You see there are 2 digits here and it's overlapping. So if I want to see the both the value, what I need to do is symbology. I can close some of this. I can click on this head. Yeah, here you have the symbology. And then in 11, what I can do is I can make this some different offset. So maybe -15. I don't know how where it will go, but you can or I can keep it like this, and then I will say here, and let's say lower left, just like that. So you can see two means two value, both the value you can see here. Anyway, now you see if this is 97 meter, 97 meter, 97 meter. Here you have 96.9, 96.9. So you can see you have different head here. So that means because the total head that you have is 97 meter. That is the head of the your tank. From that tank, depending on how much losses you have in the network, if say from here to here it's 5 meter head loss is there, then it will be 92 meter. If so, you can see there is no head loss at all in this network right now. So if there is no head loss or very minimum head loss, if you will make it to like 3-4 decimal, then maybe you see 999, 996, 992, 989. So there are losses, but very minimum losses are there. So you can see. So this is the way you can see your head loss. So that means this is showing you head loss will be in the pipe, and your junction will have head value. So head, what is this head? Try to understand this head. So let's say this what you have 90 sorry, let me make another. You started with this. I will make it like this so that you can clearly identify the difference. This is your ground level. So if it is your 82, and let's say this is 50, and this is 49. It's not to the scale. And if it is 97, and let's say this is 95. So your total head is 95 meter. But what is your effective head? Or that is pressure head, you can say. Pressure is, you know, rho G H. So rho density of water is fixed. G is also constant. So that means you can define your pressure Pascal, kilopascal in head meter. And this distance, this is your pressure head. So 95 is your total head, 97 is your total head, and the difference here, that is I don't know, 97 minus 82, 15 meter here it will be 45 meter. So this 95 is your total head and 45 is your pressure head. Is this clear or not?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So what is the actual head? It gives me an idea how much losses are there in the network with the total head, but I don't know, still I don't know how much pressure head is there. Actual means actual head at each node. So in that case, if I want to see this, then I will select here pressure head. And then I will go here and then same way I will apply this times visible and allow overlapping and unlimited overlapping. Like. So now you can see you have a head of 50 meter, 40 meter, 20 meter, 24 meter, 26 meter. Is it visible with to everyone? And here you have a head of 23 meter, 27. So obviously, if your ground elevation is high, so you will have less pressure head left. If your ground is high, your pressure head will be less because the difference will be less. And if your ground is at lower, and because it's except for head loss, means except for if I am starting from here, say 100 or 97, let's say, and depending on how much head loss is there in the system, I will have a headline here. So here it's 97 to 95 means 2 meter of head loss is there. So depends. So it will be more or less the way slope based on the head loss. So obviously the difference from this headline and the ground level will tell you the pressure head, and here you have more pressure. Clear or no clear?
Clear.
Yes,
Okay.
sir.
Yes,
So,
please.
yeah, so obviously here you can see that it was a high ground, so you have low pressure here, you have your high pressure here. Now the thing is, this is about junction pressure. You can see your the junction color: red, yellow, green, blue. So that is something purple to blue to green to yellow to red. That is the standard color given here, but it's a choice. You can click here, and this is all the color code that you have. You can give any color code to represent here. Any value you can plot it yourself. So I can say classify from, let's say, 50 meter to 20 meter and make it sorry, first make it 20, and then I will say 50, 20, and then here you can see distribute equidistantly between first and last, or distribute equidistant minimum to maximum. So now it's the color code is as per my choice. You can also color ramp. Also, you can select here. I have selected purple to blue to green to red, yellow to red. You can any color code you can select from here.
Hello, sir.
And when I will apply this,
Hello.
I will have different color code. Means different symbology reflected here. Clear? Any problem?
Hello, sir.
Then if I go here, same is water quality. I am not worried because we have not explained anything about water quality. So you will not find anything here.
Hello, sir.
Yes.
Losses are included or not?
Sorry.
The losses are included or not in this pressure head parts?
Yeah. Head loss. See, hydraulic, because you have given the roughness value to the system, so there will be head loss. But I will explain you. I will come to the head loss component now. First, at the junction, there will be no head. Junction shows you the head. Head loss is in the pipe. So when we will discuss about link or pipe, we will discuss about head loss. Okay.
Okay, sir.
So junction is clear. Tank again, it will be the same thing. Because tank is also a junction, but since it's a separate entity, same result is showing here. So it's only one value. So for one value, you can see the color code depending on the things that you will select. So if there is only one value because there is only one tank, so you can give any color which you want. So junction and tank, I think, is clear with everyone. Then comes the link. Now for the link, the main result that we see is head loss. Means what is our design requirement? Our design requirement is you need to maintain you need to reduce the head loss. The first criteria that we need to consider for this design is you should have minimum head loss in the pipe. Now, let's say okay, let me write it here. Just consider this two considerations that you need to consider. More, let me write in notepad. So, more the diameter, more the flow, and less the head loss, less the velocity. Just smaller the diameter, less flow, it doesn't look good if I write in the same sentence, but just consider it. We will consider it one by one. It's just I'm writing the heading here only. More head loss. Let's say I will not make the link. More. So just what I'm saying is just consider two criteria. If your diameter is bigger, you will have we will see with head loss. More the diameter, bigger the diameter, less head loss. A smaller dia, more head loss. Number one. But bigger the diameter, velocity will also be small. Less velocity. And a smaller dia means high velocity. Is this clear?
Yes, sir.
So that means in water supply design, okay, the main criteria is maintaining the adequate pressure. That means you have to maintain the head. But if you have very low velocity, it will affect, not only affect the water quality. Water quality is an important consideration with respect to velocity, but also try to understand this. You have a source here, and let's say this is 50 kilometer away, or let's say 20 kilometer away. You have the last house, and if velocity is very small here, let's say if velocity is 0.05 or 0.01 meter per second, can you calculate how much time it will take for this water to reach this point outlet? Or let's consider 0.1, then anyone? 0.1 meter per second. So in 3600 meter, it will be 0.36 kilometer. Then 3 hour, 1 kilometer. I don't know, means maybe 2 days or something. Means it will be much more time it will take for this water to reach this point. Means this will never get the water. Am I clear? Hello.
Yes, sir. Yes, sir.
Yes, sir.
So even though velocity, so that means velocity is also an important criteria, and that if velocity is not sufficient, then your water will remain in the system. Means this user means maybe some user is getting old water, and the old water is having will deteriorate in between, and it will have water quality issue. So also this is one consideration, that is with respect to velocity. Another is also if you are making a bigger dia, that means you are increasing the cost high. Bigger the dia, more will be the cost of the pipe.
Yes, sir.
So what we need to do is that is the modeling or optimization. We need to give such a bigger dia so that there is minimum head loss, but should have sufficient velocity as well. So it should not be too smaller dia so that you have high head loss, because this is the first and most important criteria, that you should have very less head loss into the system. And wherever, so what we can do is we can start with a smaller dia, and wherever we see high head loss, we go and increase this to the next level. So wherever we are getting a head loss of more than, let's say 3-4 meter, we will go means 3-4 meter. Let's say in some cases we will have head loss of 3-4 meter, depending on at what location of that network. It may be allowed in some cases, but we try to keep it within, let's say 1 or 2 meters. So wherever we have head loss more than that, we will increase the pipe dia. So this is what process we follow. Clear? Any problem?
Yes, sir.
Yes.
Okay. So that means let's see what is the head loss here. So obviously head loss is very less because we have already seen this, but still, if I will plot it here. And since I have done make it to a, 0 decimal, so you cannot see this value. If I will make it, so you can see some head loss into the system. And you see this is red color because here the head loss, because again you can define it as per your choice. So if you want to head loss to be defined like say more than 2 meter and 0, okay, like so. See, all is accept in the acceptable range. But so head loss head wise, I don't have any problem into the system. But is this system over designed? How will we know? Because you know we have taken only so obviously if I will put higher dia, so there will be less head loss, and we will say that my design is perfect because we are not having any head loss. Then you need to check the velocity also. So this is the velocity. And you can make it see can you see the velocity? It's very less velocity. Means the pipe dia is extremely over designed. Can everyone infer the same message from this?
Yes, sir.
Yeah, and it is expected also because let's see how much population we have considered. I don't know, maybe like 1,000, 10,000 something, 10 LPS something, 200. I have put here diameter of maximum diameter of 200 mm, and it serves only 10,000 population. So very few LPS I have put it here. Right.
Sir,
So yes.
can we represent all these dia and head loss and the velocity all together so that it will be easy to understand all together?
Yes, you can. So let me show you map. So see, only thing is it will means you will have to then zoom in and then see individually, but you can always do that. You can see here, it's anyway it's showing one is with respect to link and one is with respect to tank and one is with respect to junction. So in junction, I will select head. So you can see head value, and in link, you can either show the velocity or the head loss. Means one property of link, one property of tank. Uh, so there are other ways also, but from this screen, you can do like this. So if you want to place it correctly, what you need to do is I will go here. Let's say head. Yes, so head is here, and then I will go label, and let's say it's lower left file, and then I go to, let's say, head loss. So if I can see the head, let's say pressure or head, if you will see the head, then there is no need to see the head loss. You know the maximum, and you can also represent it here, level. So you know the maximum, and you can see the how this head loss is changing, so you know how much head loss is there. So I don't need to represent in that case head loss. So what I will do is, then in that case I will see only the velocity into the system. And for this velocity, what I will do is I will level it, then I will allow overlapping, unlimited overlapping, and apply. So you can see you have a head loss here, itna, and total head is this much. Still, if you want to present much more thing here, then what you need to do is you need to and here also you can zoom in to any level to see, but that's why seeing the value is little difficult, and that's why the color code is important. And what we do is we define this velocity and every color code as per our choice, and then just by looking at the color code only, we infer that let me show you, let me tell you this. See, just from here, I will tell you this velocity also I can represent as per my choice. So I want to see velocity more than 1 meter and velocity, let's say 0.01 or let's say 0, doesn't matter. Yeah, and then okay. So obviously velocity more than this, you can see color. So I want my velocity to be in this color, almost near this green color. So I will go here and I will have a look, and then I will see the color code, and then will infer the message from there. This regarding this vector, I have not applied. Apply then. Yeah. So none of this velocity is as per my choice. So if the velocity is there, and similarly for the pipe also, this node also I have, you can see all green, yellow. So I have high head, and in some case I have means it's blue, so it's accepted head range. So you can divide in this and if you will see pressure, so you see I have sufficient pressure in this range. I have somewhere I have a high pressure, and other place I have accepted pressure. So color code is more convenient in analyzing, but you can also plot. Also, what you can do is you can export any of this layer as a shape file, and then import and add as a shape file layer, and then present that also means then, like say I also want to see velocity as well as head loss, or as well as other component. So I will make a shape file of this, and then I will add this layer as a shape file. So then I will plot this shape file here with the value. Am I clear? Hello.
Yes, sir.
Doubt?
Sir, is there any option for optimization also?
No, this optimization we will have to do it ourselves only. Means just by inferring. It is not a direct optimization option here. So we will be doing it ourselves. We will. You can start with a small dia, and then wherever you get more head loss. So first thing that we see is the head loss. We start with where you have high head loss, and then you keep on increasing the dia, and then till you get accepted range of head loss. And then once it is designed, then we will check the velocity. And velocity normally in the main link we tend to have high velocity, and at the end you can have like even if it's a little less velocity, it's perfectly fine. It's the head that is more important. So everyone has understood till this point? Hello.
Yes, sir.
Yes, sir.
So actually we wanted to, this was our means we wanted to complete till this point yesterday only. So we were almost 1 hour delay in our training program as per our schedule. Anyway, let's go here and let's infer this message and try to correct it. As I have told you that the diameter that we have given is, is very high because we have considered a very low population, means very less population, and we have given very high dia. So what I will do is everybody need to do the same thing just to get an idea. Is what we will do is we will give let's give all diameter 50 mm. And everyone has given this.
Yes, sir.
Yes, sir.
And then go to junction, go to your WD network here on the top, and in the special tool you have distributed demand. We took yesterday 10 liter. What we will do is we will take, let's say, 50 liter. Yeah, 50 liter. And then we will take this override. Everyone?
Sir, what if I have defined the zone ID as well? So should I tick here as well?
Yes, yes. If you have defined the zone ID, then you will be getting the zone ID and demand value here. So instead of getting this value here, you will be giving the value here.
Okay. Okay.
So it's good you have done that, but because we will be also taking this exercise as well. Okay.
Okay.
So 50 liter.
So can you please repeat this? How did we open this window? Dialog
Yeah. Just go to here in WD network, a special tool, you have distributed demand.
Okay, sir. Thank you.
In this distributed demand, I have just increased this water demand to be 50 liter per second, and I have picked this override. That means it will not create a new demand, it will just override the demand. But to override the demand, also we need to give the same pattern, give this and give this residential. So it will be in the same name, same location. Okay. I think, okay. Spelling is wrong, but it's fine. So once you have done this, just I need to say compute. And you can check here in water demand, multiple demand. I have only, this residential, and okay, I have not done this leakage demand anyway. So this residential demand I have got here with the increased value here. Then I also go here again. I go back here, and in the distributed demand, let's say 10 liter, just for our training purpose, and we will give this as a leakage demand. And then I will say compute. So now I have two demand, leakage and residential demand. And oh, sorry. Just. I don't need to write override if I am creating it for the first time. So I will do again 50, and there is no residential demand here. So I need to take override only if it's already been created. So it's not already been created. So I will create here. And then I have residential and leakage demand. Now I have both leakage and residential demand. So now when I will say override and leakage, then it will override the leakage option. And this religious, let's say I will put 5 liter and 5 liter. I'm just increasing the, the demand just to give you the understanding of 5 dia sufficient. Means is it over designed and under designed? Has everyone done till this point?
Yes, sir. One question is like when we do this distributed demand by clicking the override option, it's kind of overriding everything. I mean, for example, first what I did is first I gave residential with 50 liter per second, and then leakage with 10 liter per second. And then again, I just tried with 60 liter per second by giving the category as residential. What it did is it overwritten everything. I mean, leakage is gone now. I don't have any leakage demand in the table. Yeah. If I compute it, the residential will be gone, the table. Yeah. Yeah, I see that the residential is gone. We have only leakage now.
It's must. Actually, earlier it was not the case. In the new version, it will be. I will report this. It is in this new version that this is happening. Earlier, it should have replaced only residential. So I will report this, and in the next, either they will release a bug, what you say, a new version or a small component which will allow this both. It will replace only leakage, means only the component where it's all is matching. Okay. So for right now, what we can do is we will give this and we will remove this option, residential and residential compute. Okay, so this will be corrected. This is a bug. It should have allowed it should not overwrite all. Okay.
Hello,
Hello.
sir.
Yes.
Sir, can you please check my error?
Yes.
I am getting this simulation failed error.
Length is 1 meter.
Yes, sir.
We don't give length less than 10 meter. Means that's, you cannot have a pipe of 1 meter length, and there is no need to put a pipe 1 meter away. At least you can ignore this for the modeling component. I will show you the tool. Sorry. Sorry. It's not showing here, but this is a sort of instability thing, that if you will put a 200 dia with a length of 1 meter, it's you have also given. what we will do is we will I will have a look at your model. Will check and then will inform everyone about this, why you are getting this problem. What we do is we will break for 10 minutes and we all meet after 10 minutes. Okay, is it fine? So that the other time is not wasted. We will you can have a short break now. Okay, everyone.
Yes, we can start at 11:40, sir.
Yes, we can start at 11.
Yeah. Okay. Thank you, sir.
Prasant, if you want, you can also go for break. I will be explaining. I will just have a look and then we will explain everyone basically why you are getting this error.
Okay.
Okay. So just keep your screen shared. We will have a look. I will have a look, and if you want to go, you can go.
Sir, actually, I am facing the same issue.
Yes, we will have a look on all the system.
Okay, sir. Okay.
It's the same issue everyone is getting. So I think solution will be same.
Length is a mandatory parameter, right?
Sorry.
Length has to be given, right? Length for the pipe is mandatory, right?
By default, it's calculating here geometric length. You
No,
have a choice.
Okay. The third column is just for a choice only.
Yes. If you want, like, if you don't agree with this length,
Okay.
you want to give your own length, so you have the option. It's not compulsory. Like here, in first case, the value is not given, so it will take 96.625 meter.
Okay.
How many?
तो मैं ये पूछ रहा था अभिलाष को कितने बजे बुलाए 5 o'clock ठीक है
6 o'clock बुला लो
6 o'clock
Sir, I think the error can be in the pattern. The
Eh,
thing which you taught us about the start hour.
What? Sorry.
Sir, I think the error can be in the pattern.
Pattern. It it's unstable. Unstable means there is means like if you will put some erroneous value somewhere, then it will be unstable, and somewhere it's giving some value is means that for every value, if the value changes more than 10x time, then it gives an error. So that's why I'm just trying to identify means where you have this.
Okay, sir.
It must be somewhere. I'm just it just let me check myself very quick. I will. From 10. Somewhere some value I'm just checking means even if pressure is more than whatever it's like if you are given pressure 25 and it's more than 250 pressure, then it will give you an error. So all the connections looks fine to me. Let me apply something. So everyone has. Hello.
Yes, sir.
So see, many a times what happens is it was editing error, means it was a creation error. I thought initially that it due to some wrong input of the data, but what happened is many a time when you digitize the network, I've also explained you before also that when you digitize the network, due to your means due to bad mouse which you are using or the cursor which you sometimes what happens is you go back like this and then you go. So it looks like that you have a correct pipe, but in actual what happens is from here to here you have gone back, right, which you cannot see. It's 180-degree back and forth, right?
Yes, sir.
So if this is the case, you cannot run your simulation because model will what model will have to do is the water will have to go flow like this and then flow back and then flow like this, which is not possible. So it will your model will stop. There could be other error also, but so you can see in the topology repair. One is you should not have disconnected nodes. It's self means you create a node and you create a pipe connecting that node only. From node and to node is the same node. So that is self-intersecting link. Dissolve overlap node means on the same node you create another node. Means here it's not one node, you have two node here. So obviously one of the node you need to delete. Dissolve overlap daisy points. That's the example that I have given, overlap daisy point. And then correct link connection we are missing using this. If you have a junction and you have missed the connection and it's within this radius, then it will connect to that connection. Split link on T junction with distance less than, means if you are making a 90-degree turn and you have not given a junction here, so it's just saying that if you want to split the link at this junctions. So all this needs to be checked. And in my case, I have run the simulation, but I expected that you must have also done this topology repair. I have shown you this example before. When I run this topology repair, you can see there are various types of error available in your this. That is, one is overlapping, this error. This is also overlap error, This is also overlap error. So your link and node is overlapped with each other. And that's why it's object wherever your overlaps, it dissolve the that means on one junction you have another junctions overlap, so it dissolve it removes one of the junction out of there. Clear or not?
Yes, sir.
So please,
Yes, sir. But the status, it is showing us cross mark, right? So that means the model is unable to delete that problem, or what does that mean?
Yes. If you will get this topology repair, if it is green tick, that means repair has been done. You can see the message here.
Yes.
Okay. The update from node to this and update from node to. So main thing is pipes because the flow is from the pipe. Even if I will, let's say if I put a junction here which is not connected, sorry, let me delete this. And if I go to junction, let it be. You get a message that this junction is not connected. So if it is an error, if it is not connected, if it is an error, though, you will get the message here. A particular node is not connected. Same with the pipe. It gives only the three error message. If more than 3 error message is there, then means once you will solve this, then next 3 error will come. So that means whatever the error that you are seeing here is not an error which will not allow your model to run. This means just you see here. Node junction 40 overlapped with junction 2. Go to junction. It's already deleted. Even though the message is giving it's not deleted, it's deleted. So many a times it happens. So you can see there is no junction 40. Even so, also you can check this junction 56. It's not there. So just go to topology to pair and run it again. Still it's giving a message here. Junction unlinked. Is the new all this message has gone. This is the new 3 this junction point that it's showing here. It has deleted this, but even the message that's it's not there. So this is one thing, means sometimes that is the means there is no failed message here. So many a times it does not. It should have shown the green tick anyway. It has removed the junction. But in any case, if there are means in any simulation, there are certain errors which are within the acceptable range, and there are certain error which is not acceptable. So if there is some error which is in the acceptable range, then even if it's cross or it has not been done, then it will give you a warning that it will give you an means even it's error, you will be able to run the simulation. So both things that you need to see. Number one, it has already removed the error, even it was giving a negative sign. Second, There may be a cases where it is negative sign, but that error is within the acceptable range. Like this, you have not created a split junction here. That's you should, but even if it is not created, you will be able to run the simulation. So there are acceptable range because this range we are deciding. Many a range you are deciding yourself. Dissolve overlap node within. So if I will say dissolve overlap node within 10 meter, so it will dissolve many a node, or say 100 meter. So it will give you this repair, but that is technically acceptable if it's within the range. So you need to check all these conditions. Now, only you need to remember that the minimum required, like the example that I have shown you, that is not acceptable, and your model will stop running there. Am I clear?
Yes, sir. Right.
Yes, sir.
Okay. So everyone has got the simulation now.
Yes, sir. Now it's successful.
Okay. So next step we will do. Can you let me share my screen? Prashant, you need to unshare your screen. Okay, so first we will do another exercise, and then I will explain you. Here in the hydrodynamic simulation, what we did was steady state simulation. And in this steady state simulation, this pattern was not taken care of. Whatever, because it's a constant flow. So this flow is not changing in the pipe. And that's why neither pressure nor head loss, nothing is changing in the pipe. It's a single step value. So in order to make this the value change, I need to run it in unsteady flow. That is, we need to select here unsteady period hydraulic. So everyone select this extended period hydraulic. Which collected list? What? Okay, it's about your name. So extended period, and then go to then go to simulation and everyone getting this successfully?
Yes, sir.
Please repeat the steps.
Nothing, just simply in the same simulation, what I did was I said extended period hydraulics instead of steady state simulation.
Okay.
And then run it.
It shows system has negative pressures.
Yes, so that is things to analyze. It can have negative pressure if it's not means it's not hydraulically designed correctly. We will solve all these, the issues. First, just run it, means just check if its simulation is successful or not. Everyone? Anyone
Sir,
getting error?
sir, exactly what is the difference between the exact difference steady state and extended periods?
In steady state simulation, what you are doing is you are taking whatever the demand you have given, this demand liter per second that you have given, that's a constant demand it is taking into consideration in the pipe and then simulating the model. This pattern of the demand is not taken care. This multiplier, whatever the multiplier that you have given, that whatever the flow that you have given, it should multiply by this value if the means from 0 to 3 hour. Then from 3 to 6 hour, flow will change because then it will be multiplied by this multiplier. From 6 to 9, the flow will increase because that flow will be multiplied by 2.6. That means almost 3 times. That is, if you have given 1 liter per second, then during 6 to 9, it will consider 3 liter per second. So that means the flow will continuously change in your pipe. And if means over the period in a particular pipe dia. So the pressure in a particular pipe dia, the head loss, everything will change in that particular pipe dia. Steady state is you have means over a period, like say when you are pumping from pumping water and it's a constant discharge from that pipe. So velocity and everything is constant throughout the period. That means it's a steady state flow. So you did not need to know okay, what was the flow at 5 p.m., what was the flow at 6 p.m. It will be the same flow at 5 p.m. and 9 a.m. But if it's unsteady flow, that means flow is changing throughout the period. Means at 6 a.m. it can have another flow rate from that pump, and at 9 a.m. it can have another flow rate. Are you getting my point?
Yes, sir. But our design is for steady state. At peak demand, we are designing.
Yes. Means for pattern now I am designing.
Okay.
Not only peak demand. Peak demand is like using the whatever the flow you have calculated, just multiply by 3 and then run it as a steady state flow. This can also be for the peak demand. But now I am designing for a variable demand throughout the day. Means different flow rate and different period time, means a day of the different period of the day.
That is for extended simulation.
Yes, that is extended simulation.
Okay.
So if that is the case, also extended period simulation, it's important. It is very useful when you are doing some sort of scenario analysis in real time project. Like you want to see a different scenario that from this PM to this PM, you will maintain that pipe, or you will start that pump, close that pump, then what will be the impact on the system. So all that can be analyzed in extended period hydraulic. Am I clear?
Yes, sir. Got it.
Now again go to the same result. I've already explained you how to see the result, and then let's first check the head loss. Pressure head, let me just to have a better picture. What I will do is I will just level, just have a look at the head loss. So now, you know, this head loss will be changing in throughout the time period. And also I will do just to have a better picture. This label, I will make it allow, yes, and decimal place I don't want to see. Okay, then you go to this result. Now it's 24 time step, means it can run an animation. That means when I say start, nothing is changing because it's very high head loss there, but you will see an animation if it is correctly designed. So let's first have a look of the data here. What we did from the first to this simulation is we reduce the pipe dia, we increase the demand. So obviously, if your pipe dia is smaller, what will happen? We will have high head loss. And this is means mathematically, this head loss is too much. It's more than you know, what was there, means it's going underground head. So that is too much head loss here and here. So what we will do is, now we will go to this, let's say, select this pipe. Oh, sorry. I need to first take this WRD and then select this pipe. Also select this pipe. I need to select here add to current selection, and then select this 2 pipe, then this 3 pipe, 4 pipe. I hope everyone is understanding this. You can see this pipe, this head loss is too high here. And when you will change, then you just this much only. Let's work with this much only. Even I will remove this. So let's work with this much only right now. So I go to this pipe, so selected. So this few pipes I have selected, initial pipe, and then I will give this pipe dia 100. So I have increased the pipe dia. Remember, this head loss is, you can see the head loss right now, and just run the simulation again. And I can, means if you don't want to see with the time step, let's run with steady state only.
Sir,
And yes,
so what is the exact disadvantage if head loss is more? Because we are getting less diameter, their cost will be reduced now, pipe cost.
yeah. So a smaller, like we discussed now, a smaller the pipe dia, more the head loss and more the velocity, right?
Sir,
So if I will put a smaller dia, pipe dia, obviously cost will be small, but our target is, let's say, not to get more than 2 meter of head loss from my pipe system. So that means here head loss is very high compared to what we want to design for. So what I need to do is, if I will increase the pipe dia, head loss will reduce. That we know, right?
yes, sir.
So that's what we are going to see, that whether I am able to get by increasing the pipe dia, whether the head loss will decrease or not. So what I did was, you can run with the extended also or steady state also. It doesn't matter if you want to see animation. So first I'm just checking. So even average, if I get the value with average, I can further check with the extended. So there may be minor changes during that period.
In the extended period simulation, when we are running the extended period simulation, the values which are being shown in the map belongs to which hour? Does it belongs to any hour, or is it the maximum head loss?
No, just a minute. Here in the result, when you run the animation, on the screen you get the time step. So every hour you see the value. So whenever you see a particular color, with respect to a particular hour.
Okay.
I will come to that also. Just first try. I am just trying to explain how we do this thing. So can you see, from it was something 200 something, and here also it was very high. Now you can see the value has reduced. This 41, 45, 28, 25. Can you see the difference from previous case?
Yes, sir.
Yes,
So
sir.
so head has decreased, head loss has decreased, but still it's very high head compared to what we want to design for. Means we need to further increase the pipe dia. Let's say for the same area, if I will make it 150, you can do the same exercise with me. Just try to run the same thing with me as well. Can you see? Now it's 3.9, 3.5 meter. Here you have 6.7 and 5.8 meter something. But here you have extremely high head loss. That we are only looking here. Can everyone see here? Head loss has reduced very much.
Yes, sir.
Okay. So if you can see this, then when it's in the range like 3.9, 3.5, let's have a look at the velocity as well. So velocity here is 0.6, 0.6, just to see it easily. Let me make this decimal to 1 digit. Okay, so you can also see the velocity, right? So
What is the optimum velocity which is required and the head loss which is acceptable in
see,
general?
in general, see, means the head loss, you need to understand in the sense that
And
if,
also minimum pressure requirement, how we get it?
sorry, what?
Minimum pressure requirement.
Yes,
Depends
yes.
upon that only head loss will.
Yeah, that's what I'm explaining here. Let's say my land is more or less, flatter, and I have a head here of, let's say, 15 meter, and I need to reach to this house here. This distance is, let's say, 10 kilometer, and I don't want to have a head loss of, means head of less than 10 kilometer, sorry, 10 meter. So I don't need a head less than that. Means only option that I have is I need to reach from this point to this point with a maximum of 5 meter head loss in 10 kilometer length. Now take the second same case, a little on a profile with slope land. So this is high land and same 15-meter height I have here. And here same house, but I want a more than 10-meter head here. And the land profile allows me, let's say this is 50 meter, the ground level here, and the ground level here is 45 meter. So here with same 10 kilometer length, I have house here, and so I have here now 15 meter, and here you have a head of 10 meter. So to get a head of 10 meter here, I can have a loss of 10 meter head in 10 kilometer distance. Is this clear till this point?
Yes, sir.
Yes, sir.
That
Then
means,
But sir,
what is
question
that?
was, what is the advisable head loss gradient which
yes,
is
yes,
allowed?
that's what I am coming to. Is this clear till this point?
Yes, sir.
That
Yes.
if your land is flatter, then you cannot have your head loss more than 5 meter in 10 kilometer length. If your head loss is, if your land profile is slopy, means if it allows your if you have the benefit of ground elevation, then now you can have a head loss of 10 meter in one. So here you cannot have head loss of, let's say, 0.5 meter per kilometer length. Here you can have a head loss of 1 meter per kilometer length. So the first criteria, the very first criteria to get the head loss is you need to make sure that every junction point is having adequate head maintained there. So if you will have high head loss, maybe there are certain junctions which you are not able to maintain the head with. In that case, you need to reduce your head loss further. But in general, if your means considering that every junction point you have the minimum head available in your system. So with that consideration, means first criteria That is, you need to consider with that. If it allows that, even if you are making a head loss of 4, 5, and in some case even 7, 8, it's allowed. There is no problem. Only considering that you are meeting all the head consideration for each junction point. If this is the case, even a loss of 8 meter or 5 meter head loss is not permissible. Yeah. It's not problematic. Is it clear?
Yes, sir.
But how we get to know what is the optimum diameter which satisfy those constraints?
That's like I said, when I put here first case 50 meter dia, the head loss was very high, extremely high. There was no head available at the junction. Means it was completely lost. Head, all the head was lost. And when I increased to 100 meter pipe dia, then the head loss was 20 meter, 23 meter. So obviously, if it is 97 meter and if 23 meter head loss is there, so if you will remove, make this minus 23 meter, so it will be something around 60 meter or something. This head will come and the pressure head will become very less, maybe 1 meter, 2 meter, 5 meter.
I think, sir, we need to observe that results. Like we need to check that in the like before the starting node has a good pressure and the end node has a very a good pressure drop. Then we need to increase the pipe size. So this is something, I guess, that depends on analyzing the results all along the nodes and other things.
Yes. So that's what
check whether it is permissible or not, the head loss which is coming in that particular pipe.
100% correct. So that's what we are doing one by one. What we did was we started with a small pipe dia and we checked what is the pressure that is maintained here. Let me show you. Let me to make it more clear. Let me remove this.
But it is too time consuming.
What? Sorry.
But it will consume
We can
more
do
time to check
what.
every link.
See, actually, it happens something like that, that we can sort the head loss gradient table column, and we can check it in the order of like which pipe has the maximum head loss gradient. If you increase the size of that, then there is a further impact down the pipe. The head loss keeps on decreasing, something like that. So we just have to take care of maybe 10-20% of the pipe which are critical. Rest of the pipes are like are sufficiently designed with the minimum size of elevation pipe which is allowed for that particular project.
So that's means that's what I am trying to explain. I just took few examples, only the nearby pipe. Just try to understand the concept first, and then I will let you know that how quickly it can be designed. First, try to understand the concept. Okay.
Yes, sir.
So let's have a look here. You can see here. You have a pressure here 27 meter. When I will go back again just to explain. That's why I'm saying just have a look here. Let me make it 100 again and run the simulation. You can see somewhere you have 19 meter, 19.9 meter, 16 meter, 27 meter, and obviously the value will change. And velocity is 1.3 meter, 1.8 meter. Remember, we prefer not to go beyond a velocity of let's say 1.6 to 1.8 meter. We will prefer mostly velocity in the range of, let's say, 0.6 meter or 0.5 meter to, let's say, 1.2 meter, 1.3 meter. Just try to keep in this range. Don't go beyond 1.8 meter in any case. Number one thing. Second is, if you will, let's say, if I, instead of putting this head, let me put the head here. So, or keep it pressure only and put the head loss here instead of velocity. You see, you are making a head loss of 28 meter here only. So if head loss you will keep maintaining, you will not be able to maintain the head in the downstream laser. So our target is to go near to 3, 4, 5 meter head loss, and then when we go in that range, then we will see with the overall picture. Starting with our first target is to go in that range, less than, let's say, less than 10 meter range, and then once we go there, then we will have a look at the overall picture. Here head loss is quite high. Here head loss is quite high. So first thing is I need to reduce this head loss. And to reduce this head loss, I will go and make this 150. Sorry.
Sir, and also those velocity you told beyond 1.6 is not permissible. We can guide to network that those conditions velocity should be in this limit.
Means there is a toolbox where you can define the range, but we will talk about that later. But right means as such there is no optimization tool. Okay, that is a tool where it will stop the simulation. You will not be able to means you will not be able to see the simulation. There is no optimization tool as such. So you cannot give the range that if it's means, you can only see in the animation that what is the range of the velocity. Okay, so just I have put it this, and then I will run the simulation. So I will quickly optimize this network, and then we will see. Everyone has to do the same thing for your network. So you see, head loss has reduced. I think, yeah, head loss is reduced now. You can see, but this pipe head loss is less. This pipe head loss is less. This pipe still has lots of head loss. Here it's 6.3. Let me, for me, it's very easy to do. It depends on person to person, but I don't want to see other value. Let's say, I just want to see my, let's say, head loss. So let me just have a look at the head loss. I can see, yeah, this is still 6, this 584. So I will pick this WD. And then I don't want to see the elevation also. It's easy to work with only one value showing you there, right? So I will just make it visible, apply to map. Okay, so you can easily see what is the, so I will select here, add to current selection, and then select this. This is too much. This is let me remove this also. Sorry. By mistake I clicked there. Anyway, keep doing this. Okay, so I go this and select again, then I yes. select this, and then I will select. First, I will work with the loop, and then we'll check. You cannot have a consideration like, see, the flow is going like here, go is from here. Its flow is like going here and then goes into the loop. Then you cannot have a like bigger and a smaller dia pipe at different junctions. It depends on depending on the consideration that you are doing. When you will correct it, then automatically the things will be corrected there. So if I am making this 150 dia, I can reduce it to, I can either go to 100 or less than 100. I cannot increase and then decrease again. What type of the network that you are creating, it will decide how the flow is moving in this loop network. So I have done this till this point, then I select this. Then I select this, then I select this. So this is entering into this loop and this is entering into this loop. Let's so selected. Yeah, and then I will make it field calculator. I keep this all 150. There is no much demand till this point, because remember, as you move in the pipe, go here, certain demands are met with, means in this area. So obviously the further requirement on this pipe network is reduced. So obviously you need to you can reduce your pipe dia as you move towards your end user. So I have given this 150, and then let's say run this simulation again. Just unpick this. Okay. So you can see here 6.3, 5, 4, 6, 4, and here you have 2, 3, and here you can see now your head loss is here high. So one of the thing is, from here water is dividing into, it will go either this side and some of the water will go this side. Here also, from here the total water will go in this direction only, but some of the demand is already met with. So I will, let's say, select this pipe, this, this, and this pipe. Select this. Let's say select till this point and go to junction. Sorry, go to pipe. So select. Sorry. First I need to unselect and then select, but anyway, I can do it from here. I will make this dia 100 mm. Go to map, just untick this. Now have a look here. This is perfectly fine, but this is still has, lots of head loss here. So that means still you need to increase the pipe dia this side first. So first untick this and Then go here. Uh, let's select this point and go to 5. I can put 150 also. I can put 120 less dia also. Let's go with 150 only, and then you can reduce in between also. Just I am giving an idea how to do that. There is some problem, I think. Let me check. So it's perfectly fine here, but this side I am getting high head loss still even with 150 mm dia. Right? So let's, because this is your second loop. And in this loop, you have some different dia here and there. And see, you can see this side you need to, this water will move like this to this point. And here it's moving like this. So let's this dia I can have, you can also check it in the meanwhile, you just keep on checking the velocity as well. So velocity here is 0.5 and here velocity is very, very less because I have high dia, and also there is no velocity at all because of this high pipe dia. So head loss, and the head loss is high head loss is also there because of this, different in the loop. One is 150 and another is 50 meter spike dia. So let's select this one, just first untick this, select this pipe dia, this pipe and this pipe, and this. Also make this, let's say, and this pipe dia and this. So this will be a complete loop. So let's say if I also select this, and I make all this 100 mm pipe dia. So just take this, and then you can have a look here. Yeah, it's fine. It's fine. It's fine. Check. Just zoom in here. This is why it's showing the higher dia, because here it's a boss, and I have given an additional means high demand here. And with that, this pipe dia is small. So you also need to consider these things here. Even it looks like a single pipe, but since it has high demand, it needs a higher pipe dia. So say, select just untick this. So you can see this head loss has reduced here. Okay. 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 So in all my network, except for this location, I have less than 10 meter of head loss. And since in the loop, what happens is water can reach from two sides. Water it can also reach from this side, and it can also reach from this side. So if you want to see, so first correct this, and then we will also have a look here. So let's say if I select this.
Hello, sir.
Yes.
So our head loss should be as low as possible.
Yes, head loss should be as low as possible.
So if someone getting the head loss of like 0.0 in the far end and around the 1 or 2 in near to the tank, that's fine.
That's perfectly fine if you are able to maintain the velocity, because if you will, it should not be over designed in the sense that you started with, if I simply put all pipe dia like say 200 mm, so there will be no head loss. But obviously that is over designed. That means you will also have no velocity.
Sir, I actually put it the pipe dia 150 for overall this model, and what I found is that my velocity is at the end is going to be 0.028, and at the near part it is like fine 0.370.
Yes, so that's what I'm saying is at the end junction, what you can do is you can decrease the pipe dia.
Where I'm getting the velocity less than 0.02 or 0.03.
Yeah, means wherever you are getting velocity, let's say if you just try not to go less than 0.1 meter per second, say for the first try to achieve this. At the end, if you are able to get a velocity of 0.1 meter per second, it's perfectly fine. Because you see, we are not doing house connection, means still there will be further sublines for the house connections that way. And if your velocity is not there, then it will be further it will have problem further. So don't go point less than.
Hello.
Hello, can you hear me?
Yes, sir.
Yeah, just a minute. Okay, so what I was explaining is, obviously, see, like in the first case when I had done the first simulation, what it had done is it has shown me the head loss 0.001, 0.005 only. So very minimum head loss was there. So that obviously and the velocity was also, the maximum velocity was something around 0.2 something. That simply means it's over designed network. Means because higher the pipe dia, higher will be the cost of the project. Number one. Second is, if you don't have enough velocity, end user will not be able to get the water, because it will take lots of time for that water to reach to the end user. Simple concept, velocity into time will is distance. So you can calculate if your the end user is like, say 5 kilometer or 10 kilometer away, how much time it will take for that water to reach. And in intermittent supply, if it's only for 2 hours, 3 hours, then the end user will never get the water. And even if it's 24/7 supply, there will be water quality issues for the end user. So you also even though we only means the head is the main component, you need to maintain the head, but velocity is also a criteria that you need to maintain in your system. So, and that criteria basically decides whether you are means that controls that you are not over designing your system. So you need to take into consideration both things, that neither it's under designed nor it's over designed. Under design is high head loss. Over design is very less velocity. Just if its velocity is very low, that means it's over designed. If your head loss is very high, that means it's under design. Is it clear or not?
Yes, sir, clear.
Yeah. So
Yes,
just means now if you have understood this, then it just do this. Just a minute. Just play with this, so that is the engineering. In this means the engineering concept you can apply here. This logic and engineering concept. Otherwise, all other thing is manual thing. So if you have everyone has done means if anyone can share their screen and let me know what you have designed, I can have a quick look. Can anyone show their screen? Hello. If someone has done till now, can you share your screen? And
yeah, I'm sharing my screen now.
Yeah. Okay. So yeah. So just first untick this. Let me keep the control. And let me see here. Okay, so okay.
I'm displaying velocities, but at some locations it is 0.0 is also there.
Yeah. See, it means it depends. Let's say I will come to that later. Just first check me the head loss. There are many things that you can you can consider here, but just let me have a look here. And okay, so okay. You have high head loss. You see, you have high head loss here. So next thing is, if you can see, if I go to this head, and if I take this, let's see the pressure. Okay, so bias 21, 42, 56, 30.
What are you looking, sir? How are you looking at the numbers? I mean, are you looking for some pattern or something?
No. I'm just looking at the means what is the maximum and minimum pressure that you have you are able to maintain in your system. Simple. So you now see, even with this so much head loss, you are still able to maintain the pressure. Okay. The reason being is that means it's not only about maintaining the head of this here. That means where is the setup file? If I go to this tank, and if your result, this is 85 and this is 100, means 15 meter height you have given. This is already 10 meter at higher elevation from the in general the elevation values.
Right.
Do we really need to give this 15 meter height? Because additional 5 meter height will have a very high cost impact.
Right.
Right. So if you need only to maintain a pressure of 15 meter, why to give this much height? Why not try with 95 meter height? So what I'm trying to say is you need to look into all these factors, and that will be your engineering skill, how you are designing this system. How much height means you need to keep the cost minimum, and you need to maintain a sufficient this pressure into the system. So 18, 16, 26, still you are able to maintain the sufficient pressure in your system by reducing the height by 55 meter. So why to give that height?
So we can still reduce it, right?
Yes, you see now still you are getting here 16 meter.
16.
Yes. So the minimum the head that you are getting at in any point is still the 16 meter. So that's more than sufficient because your minimum requirement was 15 meter. Now let's okay, let me share my screen again. And let's say what will happen if I break a loop? Means what will happen if I will remove this pipe? Let's say, just means where you need to create loop and where you need to remove loop. So let's say if I remove this pipe, so obviously it means there is no pipe connection here. So in that case, the pressure, the water flow will be from this to this direction.
Hello, sir.
Yes.
So creating the loop will affect our velocity and head, or it will not?
Sorry, what?
So if we are creating any loop, then
Yes.
it will affect our head or velocity, or it will not affect them.
It will affect. Why it will affect? Just try to understand. The demand now. Oh, sorry, I have reduced. I have deleted this loop also. So sorry. Have I? I don't know whether I have deleted both the loop. So you can see all this head is zero because there is no connection. I missed by mistake deleted this loop as well. So this network is not connected with this flow of water. So Control Z. I was only expected to delete this. So in that case, what is happening is there's some problem. I don't know what is happening. Let me check this connection again. There's some error. Let me delete this. And then because there is 100% head loss happening here, and so there is no pressure into the network. So maybe just let me have a look. Okay, and then if I see here, what I will do is I will find file setup file. Let's get this mm roughness. Let's say give this roughness of 110. I think I have given this to all the pipe. Yes. Simulation. So there was some error. So you can see now if I break this loop, so the flow is from this side and it goes to this, and here you can see the pressure, the head now that I am getting is less as compared to the head that I was getting when I had this loop. let me show you again by creating this loop. So from here, stamina, I will go to this layers and symbol and then remove this. And then create. Okay. And then I go simulation and then run active simulation. Oh, sorry, I created the pipe, but I'm not given the diameter. So it's saying some error. So let me give this dia, I don't know, let's say 100. The roughness at 110. Run. I could have given 50 also, but anyway. So here I have 47, 45, 36, head loss 5.7, 3.7. You can see it's 20, 19. It was something around 16 and now it's 18 something, right? Everyone?
Yes, sir.
So if you want to see the flow direction, just here, if you will, if I will click this flow. So how water is flowing, you can see. And if you want to see the absolute flow value, so you just need to, open this level. And you can see that this is 13 liter, 12.6, 12.2, 11.9, 11.6. So here the flow is, means in this direction, there is 13 liter flow, liter per second. And in this direction, there is a flow of 11.4 liter per second. So how this flow is has been divided, you can have a look here. From 13, some of the demand is met here. So from there, the flow has reduced to 12.6. Further demand is met with here, so 12.2. Further demand is met with here, 11.9. Then 11.6. From here, 11.6, two demands is met with, and then 10.9. Then 10.7. 10.6. From this 10.6, you can see 5.8 liter is going this side and 4.4 liter is going this side. Here, same way here you can have a look. 11 liter, 10.8, 10, 9.3, 8.7. How demand is met with. Then 8.7, and from here, because why it going to 3.5? Because here I have also given this 5 liter for this religious place demand. So obviously lots of water has been the demand has been met with here. If this demand was not there, this 5 liter demand was not there, then the analysis will be different. Let me have a look. Pattern. not sorry, in setup view, if I go to multiple demand, and let's say I have here religious place. Sorry. Category, residential, and where is religious? Yeah. And let's say if I make this demand 0.5.
So sorry to interrupt you, Manish sir.
Yes.
When we can call for lunch?
Maybe next 15-20 minutes.
Okay, at 1:15, we'll go for break.
Yeah.
Okay.
Yes.
Okay. Thank you, sir.
So if I run this again, oh sorry, that's not a comparative study because I have reduced 10 liter, 9 liter of flow, and 9 liter per second. So just to give you a better idea, let me do another thing. Is I go to this multiple demand, and this was 5, so I made it 5, and then I need to put this 4.5 demand. Let's go to this demand, so that just to maintain the same demand in the system. Yeah. So in order to maintain the same demand into the system, let's put this demand here at this node. So select this, and I go Johnson demand. Let's say I insert one more, and I just give this demand 5 liter, or say 4.5 liter. So I have given additional demand here, and then I go to map, and let's say some more place. Let's keep this same. This keep it as 5 liter only. So I have this demand here, Johnson, and 17. I have let's make this 5 liter. See, now when I reduce the demand, it's the total demand is the same. I have removed the demand from here, and I have put that demand here, either here and here. So demand is same, but the flow here now from 11, it was 13 point something and 11, 13 and 11 flow was there. Now it is 15 and 9. Has you noticed this? Have you noticed this?
Yeah.
Yes,
Yes.
sir.
Yes, sir.
So that means it's a demand driven analysis. That means it depends, your hydraulic design depends on where you have put the demand. If your demand distribution is not correct, your analysis will totally differ. It's not that due to a given pipe the flow in this is 11 liter. It's due to the obvious the demand that you have put on the node. That demand that you have distributed is deciding how much flow is moving in this direction. That also means that this much of demand is consumed here. Let's say you have given a 2 liter of demand here, but there is no demand as such. There is no population as such, and no water is taken here. And more water is taken. This population is here. So your hydraulic analysis will be totally wrong in that case. Because in your model, you are putting a demand here, but in actual, the demand is at this node. Estimating a correct demand is very important to get you the correct hydraulic design. Is this clear?
Yes, sir.
Yes, sir.
Yeah. So many a times what happens is the design is means estimating a correct design is very problematic. The demand, the best way is to get the demand is correct demand is you go for demand allocation. That means you have a meter installed in your network, and you have this metered information how much water a particular house is taking from its node. So in that case, that means demand is actual, and you can simulate you can correctly simulate your model on the actual demand. Number one. Number two is you install certain what you say control sensor. So you have pressure or flow sensor installed in your network at certain location. And let's say I have a pressure or say flow meter installed in the network here, and if it's showing that 7 liter is passing through here, liter per second, the flow is passing through here in the model, but in actual, if it's 10 liter per second, that means you have given a wrong demand this side, and then you can again work on the model to correct your design. So if you have certain control calibration point, measurement station, so you have any at junction or in pipe, you have, if you have measured a measurement file and you give the observed value here, it will take the model value from the ID that you will give. So any let's say if you have installed a flow in the pipe, and then you give that particular pipe where you have this flow meter installed, and then for that you have the flow meter value here. So you have a discharge time series. You can select the discharge time series, and then it will give you a plot how much so what is the flow your model is giving and how much flow your meter is giving, and then you can accordingly modify your meter. Like say if it's 9 meter absorbed and 7 meter, that means you need to increase the demand there, that side. Is this clear?
Yes.
So how you correct your design? Number one is you have sensor installed in your system, and you correct your design according to that. Second is you have metered installed in your system, and you that detail you provide it here. So these are the two options that you can correct your model. Normally, what happens is, let's say, means because many places, especially in villages or somewhere you live, you provide, open pipe on the road or somewhere, and the wall gets stolen and it will be continuously leaking from there. So that's lots of losses inside, and that's nothing means for model. Basically, it's the demand. For model, you in that case you need to put that much demand. Either you put in any category, in leakage or in population demand category. But that is the loss. That is the removal of water from the system. And unless and until you provide that information in your model, you will not get the correct hydraulic analysis here. I hope I am clear till this point.
Yes, sir.
Yes, sir.
So now you have a fair idea about this hydraulic design, I think. Can I assume this, that you have a fair idea of hydraulic design, so that I can go for some specific analysis? And one of such analysis is, due to this, means inability to have a correct demand distributed at the correct junction point, one of the options is pressure dependent demand. And in the pressure dependent demand, it's not the demand that controls the flow in a particular direction. It's the pressure demand. How much pressure you need at a given junction. So if I need high pressure this junction, less pressure this junction, or if I need, you can give a range. Means here, I will go in detail after this break, but just I am giving a idea that what is the required pressure that you give and what is the minimum pressure in your system. And the model will optimize the flow as per the pressure, the required pressure that you have given in the system. So it's not the demand driven flow, it's the pressure dependent driven flow. And that's in many cases observed to be a better estimate of your network if your population demand is not correctly explained in the model. So what we will do is we will, because we need to break for lunch, so I will start after break only. Pressure dependent demand. If you have any question till now with respect to demand, means what the simulation we have run is demand driven simulation. If you have any question with demand driven simulation, you can ask. Otherwise, we will break for lunch. Anyone? Any question?
Yes, sir.
Yeah.
So like if there is a fire station and the pressure at particular junction of that, the pressure requirement is very high, but in other nodes, the pressure is minimal.
Yes.
In that way, how we can control the pressure at one junction?
Yeah, so basically there means when I will means after this pressure dependent demand, we will go to understanding of pump and valve, and then when I will explain you the valve thing, then I think you will get your answer.
Okay, sir. Thank you.
So through valve at different section in our pipe, we can control the pressure in a particular pipe. Number one. Second is we can also do is even with a given means we can also check in the current network only for with a particular pressure how much flow is available there, and for a particular flow how much pressure will be, means depending on the pipe size that you will apply to take the flow from there or pump the water from there, from your network. So you give either that, okay, you need a flow of this much. Then it will tell you, the system will tell you with how much pressure you will get that flow. So if your flow is less, you will get high pressure. And if your flow is high, then you will get a low pressure. So depending on firefighting, means which building fire you need to douse. So accordingly, you can decide on flow and pressure. And that's an important analysis in real time. So I will also show you how to do that in real time.
Sir, also in extension to my query, is there any dedicated reservoir for fire service station other than ESR?
We put hydrant. That's basically means different types of hydrants. You might be seeing somewhere a pole kind of thing. That's a hydrant, and many places it's a blue color, red color, depending on how much flow you can extract from there. So yeah, we in the network itself, while designing this water supply at important junctions and near city, near market, we put hydrant with high capacity, and then we include that demand also in the network, so that when required, that flow is there.
Okay.
So yeah, there was one more question.
Sir, in case of a looped connections,
Yes.
what determines the flow direction?
Demand in this case demand, and when we will do this pressure dependent demand, then in that case pressure requirement will derive.
Sir,
Yes.
sir, actually in demand, we know the total demand and we are distributing the demand by some methods, by using some methods.
Yes.
How much accurate we can say this demanded junction? How much percentage accurate? Because we don't.
It's then that's what I say. The best way is to do it with demand allocation. In your case, the method that we have used right now, if I assume that my network is uniform throughout, means where I have considered I have considered uniform type of design in my network. Like it's not that in one area I have designed in up to the house connection, and other area I have only created a main line. So because it's about the pipe length. So if that is the case, if the population across your network is uniformly distributed, in that case, the method that we have used will be like very accurate. But if, like say, I have created like this, and there is more population is on this side and very less population in this side, then it will not be that much accurate. Then in that case, you need to go for another method. That is, maybe you can, for each node you can assign a service area, and based on the area which is serving to, it will calculate the demand, and that will be more that will have much better accuracy. Am I making myself clear?
Yes, sir. For all this, we have to do survey then.
That's the means ultimate the thing.
Okay.
Also, but it gives you with this background, it gives you a fair idea how this population is distributed in this area.
Okay.
Right.
Okay.
So
Yes.
so with this consideration that the population that is distributed here, it's fairly fine, that the method that we have used here. But there will be cases where you will have like very high population, like unplanned colony somewhere with very high population, and other places maybe very less population. In that case, what you can do is you can go for zoning. And I will explain you the zoning after break also. So actually we need to cover a lot, but if this is clear, I actually yesterday we missed almost 1 hour due to some issues. Some of the tool was not working here and there, so some time was lost there. So maybe today, if it's okay with everyone, we can go till 6:30.
Yes.
Okay. Thank you.
Hello, sir.
So,
Sir, one question, sir.
yeah.
Sir, when you were telling about that minimum velocity consideration,
Yes.
so you mentioned that the time will be very much high and the customer will get the water after very much long time.
Yeah. If velocity is very low. Yeah.
So yes, sir. Sir, can the software tell me that the water will reach a particular junction after what time from the tank?
Yes.
Because it knows the
Yes.
length also.
Yes. So that is if I will go to water quality and then
Screen sharing, sir.
okay, after break, let's not
Okay, sir.
delay it here. I will explain you. You can do water age analysis. This water age analysis is nothing but simply tell you how much how much old that water in that network is. That basically means how much time it takes for that water to reach the outlet, right?
Okay. Yes, sir. Yes. Fine.
Yeah. So with the you can do the water age analysis. You can also do source identification if you are supplying the water from multiple source. So you can identify a particular node is getting water from which source. So means I'm giving you a very basic idea about this water supply system. There are lots of analysis that you can do using this tool. We will try to cover as much as possible. Okay, after this break. So let's meet at 2:15. Everyone, if it's okay with everyone.
Yes, sir. Yes, sir.
Okay. So we will start at 2:15.
Okay, I'll just put this word forward. If you have any corrections to be made in the details, please let me know by 3 o'clock, and we'll have a closing session at 5. We may continue the training after that, but our managing director, DHI India managing director, will address. And again, I request you, if you have any queries apart from this day, afterwards, evaluation license will be provided to you for 1 month. And you can email me if you have any queries related to this training, your feedback, anything you want to say, please feel free to email me. Yeah, thank you. Yeah.
pipe dia that is available in the market, readily available in the market. You will also get the thickness of the pipe dia here. If you will see, for our study purpose, we have just taken the thickness, 0 mm. But in actual, if you will see that every pipe will have certain thickness, and this thickness you can provide. So it will calculate the inner dia based on that, the wall thickness and the diameter that has been provided. Here, the wall thickness we have just for our exercise purpose we have given this figure. Also, actually, when you purchase a new pipe dia, this roughness value is also provided by the client only. That what is the roughness value of the given pipe. So refer to manual to see the actual diameter of the pipe and or the actual inner pipe dia that is available. We have measured after considering the wall thickness, and you can take those values for your analysis. Okay.
Okay, sir.
So means here I can design it like 200, 210, 215, 220 pipe dia, but that is not available in the market. Na? So you cannot put that pipe dia. So technically and practical consideration both you have to take into account. Technically, you can put even 210 mm dia here, but is it available in the market? That you also need to check.
Sir, it depends on the road width also, no? Like
road, not exactly, but or say directly. In obviously, you will not design. Let's say there is no road here as such, or only passenger or what you say, means only a small person can walk from here to here. So obviously, you will not put your pipe dia on this road. So if it's because you need at least you need to excavate there, and then you need to put your pipe, and then you need to cover it. So if building is both side and there is no space for excavation or something, you cannot excavate that. And similarly, in the collection system, you cannot put a 1 meter dia on road which is only 1.5 meter thick. So it will not be possible for you to put that pipe dia. So yes, practical consideration has to be taken care everywhere. So while designing, you see this. But if I talk about normal road width, like if it's say 5 meter or 10 meter wide, you can easily put 200 or 250 mm pipe dia there. This is or 300 mm pipe dia there, which is in general the pipe dia length for your design. Am I clear?
yes, sir. Yes, sir.
Okay, so here you are getting here a head of 10, 11 meter only. I can see. It's better if you will put it like in one dot, then it will be more easily visible on this dia. But anyway, here I can see you are getting somewhere you are getting less than 10 mm dia, and velocity is also somewhere it's at the end, it doesn't matter. 4, 3. So 0.7, 0.07, yeah. So in the you can see it means if I consider this that this is the actual end user, means you have designed till house connection, then this is fine. But if there is more house connections going to come out from here, and then maybe if the length from here to the house is still very large, then you need to reconsider the pipe dia again. Anil, is this your note?
Yes, sir.
Yeah.
Yes,
So,
sir.
so,
Yes, sir.
so I hope you understand. Like say, we have
Yeah,
just
that's
for
what.
example.
It is an end connection. I understand, sir. If it is an end connection, the velocity is not a problem. But
Yeah.
if for instance, we are designing it now, but if the network expands later and this has to be taken further, then that would be a problem.
Yes, exactly. So if I assume then it's fine. Means if I assume it to be the end user, then it is acceptable.
Sir, particularly where you can see at the top a green line, there it is 0.03, which is which might, I think it is very less velocity.
Where? Point
The green one, sir, which you can see at the top, green line.
Okay. Hey, is this?
Yes, yes, sir, yes, sir.
Okay, let me just zoom in. Yeah, 0.03. Yeah, it's very less. But again, I think your pipe length is also very small. Let's see the pipe length. It's not selected.
It's not selected, sir.
It's the color.
I think I have taken out the WD check mark. That's the reason it's not taken.
It's 38 meter. Means that means 3 houses. So it will be only house connections from there. So it's okay. Are you getting my point? Means 38 meter means you cannot have more than 3 houses along that road.
Yes, sir.
Okay. So means because one road, let's say, has a width of 10-12 meter, so 3 houses.
Yes.
So that
Yes,
can, because that's more a sort of house connection kind of thing. So if that is the end node, then uh, that's fine. Many a times in practical consideration, you will get this error that in many places you are getting very less velocity. But again, I said velocity for you important only for travel time, means whether that they will be able to get the water or not.
Yeah,
So yeah. So main thing is the head, means if
head
you put a
pressure.
pipe,
Yes,
perpendicular pipe there, the water can rise to the top of the building.
yes, yes, sir. Yes.
So,
Okay.
but if this would have been like say 300, 400 meter, then this velocity is low, and then you need to decrease the pipe diameter. Okay.
Okay, sir. Okay.
Okay. So I think we can start. Please unshare. I will start our next topic. Okay. So before lunch, we started discussion about pressure dependent flow. Okay. So let's delete this, go to junction, map, and then I delete this point. Okay, so we discussed till this point. We have analyzed our network and we have understood how you provide the pipe dia and how it is demand driven. But again, let's say here, just assume a scenario. Let's say you can see the pressure here is 31 meter, 31 meter. But let's say the required pressure here was 15 meter, and the pressure here is or the minimum pressure that was required here was, let's say 5 meter, and the pressure here is only 3 meter. Then what will happen? There will be no demand fulfilled from this node. So there will be no flow out from this node. So this demand driven gives you the pressure, but it does not take into consideration what will happen if there is no pressure or minimum pressure is not maintained there. In general, in actual, if minimum pressure is not maintained here, then the demand, there will be no demand met with here. Is this point clear?
Yes, sir.
Yes, sir.
And if there is no sufficient, means there is only one is minimum pressure required, means to get any amount of water, there is some minimum pressure required. At least just for understanding purpose, just see this is your ground and this is your pipe. At least you need this much pressure to water to reach to the top, to the ground itself. So 1 meter is required only to just reach here. You need certain pressure here so that you can use water. You can extract water for even to fill your tank or something on the surface. You need some pressure. So let's say if minimum pressure is 5 meter, so if anywhere on the system, if minimum pressure is not met with, then that demand is that much amount of water is not supplied. Now, if your pressure is more than minimum, but it's not up to that required pressure. So obviously, if the pressure is more than required, so you will get all the demand fulfilled. But if pressure is low, many a times you will feel that at your home the flow is very slow. You are not getting enough water. That means the pressure is not there in the pipe. There is not enough pressure. So obviously, what you are able to do is you are able to collect few buckets of the water. You are not able to get the sufficient amount of water during that period of simulation or during the period of that water supply. That means your water supply is reduced. The actual demand is reduced in that case. Is this clear till now?
Yes, sir.
That means if that water is not extracted here, that means that water remains in the pipe. So the flow condition will change in the pipe. So what you need to do is, so that's why there is another option, pressure dependent demand, which consider the pressure requirement, minimum pressure and required pressure into the equation, so that you can modify your the actual means just the terminology is demand only, but it's the actual extraction of water. So actual demand is the actual extraction of water. So basically here the demand was 2 liters per second, but since the pressure is low, it's less than the required pressure. So I will, instead of getting 2 liters, I will get only 1.5 liters. That means the demand has changed here. And we have seen before that when you put a demand at other location, means if how you have defined the demand at node, your hydraulic condition changes. So what we will do is, we will, based on the pressure requirement, we will calculate the actual demand. And so if everybody please go to this pressure dependent demand. Here you will see you have two options. One is minimum pressure and another is required pressure. But what will happen in actual is, maybe this area you have 2-story building, this area you have 1-story building, and some area maybe if it's let's say multi-story, 5, 7, 8-story building, then normally it happens is you don't need that much pressure, like a 50 or 80 meter pressure. What you need is, you need to provide water to the sump, so that colony will get the water in some storage, underground storage, and they will themselves pump that water to the top. So in that case, again, your demand is not that high. So basically, but in general, if it's 2-story, so you can give individually how much is the required pressure here and how much is the required. Maybe here the required pressure is 15 meter, here the required pressure is 10 meter, something like this you can provide. So I have this option that I can give a global pressure demand, or I can create local pressure dependent demand. So if you want to insert a local pressure system, you can create a local pressure system. And so you can give this minimum and required pressure at all the junction point, or to you can give a common pressure for all the area. Is this clear? Hello.
Yes, sir.
Yes, sir.
Okay, so let's say the minimum pressure required is 5 meter and the required pressure required is 15 meter. Now, if my system has all this flow more than 15 meter, that is means more than required pressure, then obviously it will not change my initial analysis. Let's have a look at the formula just quickly. The new at all junction point, this formula will be applied. That is, the new discharge, that means the new calculated discharge will be the original discharge. Original discharge is the discharge that you have calculated based on demand driven analysis, means that we have just calculated. We have seen how much flow is there at each junction. So you know, or in each pipe, so you know the original discharge. So original discharge into P actual means that is the from the demand driven. You have this this pressure value at each junction point. So you have this pressure, that is the actual pressure, minus P minimum, that is the minimum required pressure to extract any amount of water. If less than P minimum, no extraction at all. So the extraction will be 0. So P minimum is, let's say, 5 meter, and P actual in this case is 30 meter. P required is 15 meter, and P minimum is 5 meter. So you give this 30 minus 5 upon 15 minus 5. Then multiplied by this into 1 to the power n, and n is a coefficient, and in general, normally this value is from 1.5 to 2, but in most of the cases we take the value of 2. So that means 1 by 2. So you will get certain factor here, and you will multiply this original with that factor, and you will get Q new, discharge new. Is this equation clear?
Yes, sir. Yes, sir.
Yeah. So you have modified discharge if you are using this pressure dependent demand. But again, like I said, if you have, like, if I will say here required pressure is 40 meter, then my discharge will change, because now in not all location I am getting a pressure of 40 meter. So obviously at not all location that demand the discharge will be the demand will be fulfilled. So I will have a new discharge calculated at the junction point. But if my system already has more than required pressure in the system, then there will be no difference in the from the calculation. So this is a consideration. Means you can modify, you can further improve your the demand allocation with this pressure dependent demand, and it will be more logical if you will give considering the actual consideration at a different junction point where you have different requirement for required pressure. So one you select this minimum and required pressure, then you need to select the formula, and the formula that I have explained is the Wagner formula. Concept remains same, but they all use this some different little modified formula. So this formula is called the Wagner formula. You can refer to manual to see the all different formula, but the concept remains same. Only the factor of multiplication with the original data will change. So let's select this Wagner formula, and this exponent is n value. This n, which I say that you can take it in Wagner formula, you can take it from 1.5 to 2. In most of the cases, we take it 2. So root under you get a certain fraction, and that you can calculate.
Excuse me, sir.
Yes.
Sir, in actual scenario, if we see, we generally do. I don't think we provide a global setting.
Yes,
On a practical basis, we give.
Yes.
We give a junction. At the junction, we give pressures and also the demands. Everything we give on the junctions. So on APANET, there is a feature where we can give all the data on Excel and then import. Is there any feature where we can import all the data so that the time would be minimized?
Yeah, so basically what you need to do is you need to insert, and then it means just all the junctions means see here you need to first create all the junctions, and then this data you can copy paste from Excel, or you can copy this data to Excel, modify there, and then paste it here again. So any table that you open here, you can just copy this in Excel, modify it, and paste back here from the Excel. That you can do any individual column or the whole scene. Also, means, not for this here, but here you can also apply the field calculator. Means, but we will have to first create for all the pressure dependent demand. This number of junction point you need to create first, and then you can apply the formula. Okay.
Okay, sir. But
sir,
sir, one.
Carry on.
Yes.
Yeah.
So just you are 100% right that like I said also that we give on local node only, but let's assume that it's for all it's the same required and minimum pressure. This also means that the same pressure you have given for each node, each junction point. So if you are giving the same pressure for each junction point, instead of creating a individual junction, I have given it a local value, means a global value. That means for all junction, the same pressure will be applied. Otherwise, you can insert and you can give the individual pressure separately. So let's say, if like 10 junctions, the requirement is 10 meter, and other junction requirement is 15 meter. So in that case, I need to create only those 10 junctions where I need to give a different pressure. What it will do is, first it will take the junction point where local pressure is given. For all other junction point, it will give this global value. So the maximum junction point where you have this this pressure requirement, you can give in global, and where it's varying, you can provide in the local also. You can ignore this and provide individual value for all junction in the local value only. So first preference is local value and second preference is global value. Is it clear till now?
Sir, it is clear, but one thing, sir, since we when working on a actual scenario, we'll be anyway giving local nodes. Wouldn't it be convenient if the nodes are generated automatically once we provide the junction points there, so that if we require, we can just copy the thing.
Let me tell you why it is not given. See, when we are designing, it will be very very less case where you like this area. Normally the required pressure will be one value only. Maybe I mean, for a particular colony, for a particular area, you will need a similar type of pressure requirement. I don't think there will be, means you will find a case where each node has a different required pressure. We give them the required pressure when we design this system. Like here, if I have given this pressure, that is the required pressure. So required pressure, we have given uniform. That means in most of the case it's uniform only. Maybe there are one area where it's only jhoppi or one story building, another area it's it's totally all two-story building. Then you may need to differentiate between these two places. So not individually for each node it is required, and maybe most of the things this global pressure will cover, and all other junctions you can create individually, and that's why this option is not given. But it's just that if you want to insert, you can insert individually. You can insert to all nodes. That doesn't matter.
Sir.
Okay, sir. Okay.
One doubt, sir.
Yes.
You told at one junction if 20 meter pressure is required, if you provide more pressure, demand will decrease. You told. I am unable to imagine that.
No. I am not. just let me clarify that. I said you have one is required pressure another is minimum pressure. In PDD, pressure demanded, two options is there. This minimum pressure is the pressure which should be there to extract any amount of water. And this required pressure is to meet the demand that you have given at that junction. Means a pipe is passing through here to extract any amount of water, even let's say 10% of water also, if you want to extract out of the demand, you need a certain minimum pressure to get that water. And required pressure, that is 15 meter, you need to get the 100% of demand that you that a person, a house want here. So if it's 2-story building, you need a pressure of 15 meter. Let's say that means if pressure is 10 meter, this person will not be, may not be able to get meet the means the 100% of demand of this person may not meet, maybe a little less than that, 95%. Many times you will the practically can see when sometimes you have very low pressure in the pipe, and your the tank at the top of the building does not get filled due to very low pressure. Many times you will be able to fill a bucket or two only, and not it will not even reach the tank. That means if pressure is, because there is no pressure, means less pressure in the pipe. That means if pressure is less, you are not able to meet the 100% demand. If the pressure here is 20 meter, then there is no need to do this calculation. All 100% demand is met with. So this required pressure and minimum pressure, that is only means your pressure will your actual demand, means actual extraction of water will change between this range. If it is less than this, then no flow. If it is more than this, 100% demand is met with, and there will be no change in your system, even if you are running this PDD. This is what I said. Any problem in this?
No, sir. Okay.
Okay. So let's just for this, just you need to give this value individually, and then you can run your model.
Sir, I want to know one thing that I have missed because of the poor internet. So, sir, when we run our systems in the result, like we have pipes, so how can we check the head loss gradient and all the things?
Sorry, I don't.
How can we check the head loss gradient in our system?
We have okay. We already covered. You see.
Yes, sir. I missed it. So just quickly, if you can let me know.
Yes. Okay. No problem. Actually, when you run your result is uploaded here, and the same layer is also uploaded here. And in this layer, you will see that you have junction, you have tank, and you have link. And if it is not uploaded here, say whatever reason, or you have already the simulated result with you, but you have closed this the model, and now you only want to see the result. So you can add layer without simulation. So you can here you can select the my result file, and then you can it's by default here. So I will go here and I can add this 11. See. Not here. Here in the result, you can add 5 here. So only you want to see, you can also add layer in any result layer. this is the result here. You can upload anytime later also. So anyway, whatever the results layer that is available here, you can also see the see symbol here, layers in the layer and symbol. And in the layer and symbol, in the link, head loss will be from the pipe. So in the link, you can see you have head loss per 1000 unit. Means if it's a meter, the pipe dia, then per 1000 meter, that means per kilometer, what is the head loss that you can see from this pipe, this value. And just tick this, and then if you want to present here color code and everything, you can classify from here, and you can label the head loss value from here. Is this what you are asking?
Yes, sir. Yes, sir. Thank you.
Okay. So that's what actually we see the result here, and based on that only we model our system. We increase or decrease the pipe dia to check if what will happen is you can do n number of scenarios. In the junction, you started with sorry, in the pipe, you started with a certain roughness value. What will happen is as this get old, your roughness value will change. Also there will be, if it's old or there is some losses, you can increase the loss from there. And whatever the changes you will make based on that, and you can run your system again, and then you can this in the model, and you can check whether you are able to maintain the pressure correctly or not, and where you need to replace your or let's say due to whatever reason another colony has been developed after 5 years here with lots of population here. So you need to increase the pipe dia in this reason. So you will do this in the modeling, will check the scenario complete, and based on that the suitable pipe dia will replace here. So you can use this modeling component not only for upgradation of the existing system also. I hope I am clear. Hello. Okay, so I assume I am clear. So let's go to pressure dependent, and then see means like I said that in this case since 100% demand is met, which means because my pressure is more than 15%, so I am getting this value. Otherwise I would have got the value like the demand. So this way you can get the demand. You can also plot it here for individual. You just create any individual junction, and then select the junction, and then plot, and its graph will be plotted. How much percentage of demand is met with, and what is the demand there. And if it's individual node, then for each node you will get what was the demand requested, what was the demand delivered, and percentage demand met with. So this is about pressure dependent demand analysis. Any question in this?
Sir, practically a head loss gradient like it is as per 1000 units. So if it comes 8.85 or 8.95, so what does it mean as a practical? Practically, how does it matter?
That means if it is, let's say, 100-meter pipe, and 8.5 meter is the loss per kilometer.
Per 1000, yeah, 1000
per
unit.
kilometer. So,
yeah.
So that means the actual loss here is only 0.85. Head loss in actual is 0.85 only, not the this for in this 100-meter pipe.
Okay. So as per the ideal scenario, what it should be? I mean, it should be the minimum.
It should be means the range that we always head loss that we see is in per kilometer. Means the value that I have explained 0.5 means 4 or 5 or less than 10 meter head loss in different conditions. It's per kilometer.
So how much it should be? Like it should be in 0.5 or it will be better if it comes under 10.
Per kilometer it should be less than less than 10 meter or it's preferably to be in the like 3-4 meter, not more than that. Again, depends if it's a horizontal area, uniform, no gradient is there, and then in that case you would like to have even a smaller head loss.
Okay. So, sir, it is decided by the CPHO manual or something we.
See, yeah, CPHO manual also, and your pressure design criteria means how much pressure. I have explained in the morning also. If let's say if here is 15 meter height you have given and all horizontal is there, and let's say this length is 10 kilometer, and the minimum pressure that you want here is 10 meter. So you cannot have more than 5 meter this part in this 10 kilometer area. Otherwise, you will not be able to maintain the head here. So even though you can have more head loss, but in this case, if you will have more head loss, then you will not be able to meet the head criteria. So you would like to have less head loss here.
So in order to reduce our head loss, what should we do? Like we have, like suppose we are getting
a head loss. If you have higher the dia, lesser the head loss. Lower the dia, lower the diameter, higher the head loss. So if your head loss is high, you will have less head loss, and if your diameter is smaller, you will have high head loss. Number one. And second is if you have higher dia, you will have a smaller velocity, less velocity. So you cannot go. You cannot extend, increase your dia to infinite level to reduce the head loss. Then in that case, you will have very, very low velocity, which is also not preferable.
Okay.
So you need to optimize. That's the optimization is you need to have enough dia so that you have adequate velocity and no head loss. And we did the exercise, same exercise in the before lunch, where I started with 50 meter dia. First, I started with 200 mm dia all, and I have seen that there was no head loss because that was sufficient, but it was also having problem with it was having no very, very minimum velocity. So that was over design. So I took another example, second case, where I gave 50 meter dia and also increases the demand. So obviously, in that case, what will happen is this diameter now is not able to carry the water, means there will be, because dia has become smaller, the head loss will be more. So then head loss has increased. Now head and velocity has also increased. So if velocity has increased, is preferable, but if head loss has increased and it has increased certain beyond a certain level, like say 40 meter per kilometer or 30 meter per kilometer, then I will not prefer. So I started increasing the pipe dia till I get in the range of 3. You can see 3 to 7.9, 6.9, 3.8, 0.7. So this range 6.6, 6 per kilo. These are per kilometer. This range. So I will keep on increasing till I get in this range the head loss. And so this way you will be able to maintain the velocity also, and you will not under design or over design the system. So this is exactly the exercise that we did before lunch. Is this clear?
Yeah.
Okay. And
So
then
can we have the flow direction in this model?
yes. So just click on here, this flow. You can also put, this the arrow. You can also modify the color coding and everything how you want to see here, but it gives you an idea that how the flow is happening in your network. And you can also see not the flow direction, but also see how much flow is happening. Means 15 liter is moving in this direction and 9 liter is moving in this direction. And then 9.2, then some is used here, then 8.5, then 7.8. So you see how the flow is changing in different pipe diagram. So all these things, everything you can analyze in the system. And we also did one exercise where I changed the demand here in this pipe. And with this flow, flow, I can increase the demand or I can reduce the demand in any point on this network, keeping the total demand same. That means initially I have given some flow, additional flow here. So I move this flow to this direction. The flow pattern, it will change. And accordingly, the pressure and everything will change. The hydraulic condition of the pipe will change. So that's why it's demand driven. And that's why we modify it to based on the minimum and maximum required pressure condition. That is pressure dependent demand simulation. So I can include this component for global as well as for local component. So this is till this point we have done this exercise.
Okay, so that means we have not discussed yet about the valves.
Valves, no.
Okay.
The pump and valve. If it is clear till now, then I will go to this pump and valve. Before going to this, I forget. Someone asked me about negative pressure in the morning. Who asked that? Someone asked me, but anyway, you can get negative pressure in normally two cases. Number one is let's say your tank is right now is 97 meter, and if some of the road is let's say 100 meter, then if your pipe is above that the supply, then you will get negative pressure, number one. Then unless until you are pumping that water. Second is when you have very high head loss. So it's like if it right now you have a head of pressure head of 27.6 meter, but if this head loss is like say 40 meter or 30 meter, you can have negative pressure. If it is extremely high, then you will not see any value here. But that's also a sort of a negative pressure beyond a certain range. It will not show you anything. That's an error. But these are the two conditions for negative pressure. Whoever asked this, but your task is to avoid negative pressure. It means you should not get negative pressure in your system, this hydraulic system. Then coming to so if you have designed this network, then we will move to the next topic, that is pump design. So let's see.
Sir,
in that, yes.
Just before pump design, this pressure dependent demand which you have calculated, can you explain this graph, what it says?
Yes. Let's say, let me do one thing. Just take any node. I don't know which node is there. Just the required pressure is, I don't know, 60. The minimum pressure is, let's say, 20 meter. Just erroneous value I am just putting just to give you an idea. Then I run the simulation. And then if I go to this report, let me see which junction is this. Map, select all. This is my junction number 10. Yeah, so this is my junction number 10. And if I go to lesser head here, it's 41.3 meter. So that demand is 100% met with, but it's already high pressure here. Let's consider this for some other node. Which node? Where you have low pressure somewhere. Let's check. And let's consider this. This has 25 or let's consider this is node number. Junction number 5. So let's consider for junction number 5. basically, let me see the report. You are not getting it, but you should. Okay.
Sir, will this run in the steady state simulation or does it require to be in extended period simulation?
It can run in both cases, but obviously that will be more easily depicted if it's extended period simulation, because sometimes you will have very high demand, and other time you will have less demand. So you can also check there, but it doesn't matter in case of that analysis. You have got it, but you should not have this issue. But anyway, this is what I was explaining. Is your pressure, the minimum pressure is 20 meter and the required pressure is 60 meter. So sometime when your flow is, you can see here the result. If I will start, you can see the timing here. And you see, just pause it. Sorry, just go back. You see, at this time, it is 15.8 meter. So your demand will decrease. Means the flow will decrease here. Because it's less than 20 meter, which I have defined as 20 meter. And then sometimes you see the demand will be more than, and then sometimes it's less. And you can also plot instead of pressure link, you can, yeah, the flow value you can see it right now is 0.2. Okay, you can restart the simulation. This is the flow value. You can see. So 0, you see, it just need to increase to double more digit to see the value here. So if I go here flow, and then if I increase this level value to 3, you can see the value here. And let me tell you why you was not able to see that in that case. It was because the line would have been on this line, because it's a one single value. So single value graph will be like a straight line, and it was not coming on the anywhere here, but it will be like on this. You can see you have a different range here. And when you run it with steady state simulation, oh, sorry, Mm. You see, range is 99 to 101. So you cannot see it even if it's like here. You cannot see the range value, and you cannot see this value here. So one time step does not make any sense. If you want to see the pattern how it's changing, you can go to this extended simulation, and then you will have a clear picture of how whenever you have less flow during that daytime, the demand will be less met with. It will remain in the system, and it will change the hydraulic condition at other location. Yeah. So if this is clear, everyone. So you can see here is something around 99 is start is 100, then it goes here and then it reduces because your flow is the pressure is because your demand you see it's going up, and then so it's same. Here your demand here you see it was a single value that is 20 liter per second in one go, and it was approximately 99 something percentage in single go, and it was on the line. But from the range you can get the idea that the range was very small and all value was on a single value on this line only. So here it was 99 to 100%. So now it is 10 to 100% because of this the factor that you can see. So when your demand is increasing during daytime, your demand percentage that's the percentage net demand is decreasing. So this is the actual demand you are able to met with for that location from the actual demand. So whatever the actual demand was there, you were able to meet here only 15 to 20% of that demand, and here you were able to meet with 100% of demand here and here. I hope I am clear.
Yes, sir.
If I make it to, let's say, minimum pressure, let's say 10 meter, and the required pressure, let's say 20 meter, or say here 5 meter and 20 meter, like that. And then if I run this graph again, I don't know whether the flow, this demand delivered has it changed from before. I don't know. This curve has changed or not, I don't know. It should have changed. I think pressure is going below that 20 meter also. Let's see. Map. Here I can go and I can run the animation. It's going to 15 meters. So it's still 1.7 also. It's going to 1.7 also. So when it's 1.7 pressure, whatever that you will not be able to meet that demand. So when pressure is 1.7, you can see. I think it was in the second time step only. Step forward. 20, 15, 15. So all this point you will not be able to meet the demand. And then if you go to further 25, you see negative flow, negative pressure, and demand you are not able to meet during certain period of the time. So if you are not able to meet the demand, so it's just showing you the graph how your demand is met with. Because what is happening is, just have a look here, pattern. Whatever the demand that you have given, it's it's multiplying this. So it will, the flow will be 3 times that demand during this period. Sorry. Just a minute. So sorry. So if demand is made 3 times into this pipe, obviously you will have more head loss. And if head loss is high, then in that case, you will have less pressure available here. And in some case, negative pressure. Is this clear?
Yes, sir.
So a steady state flow was with respect to this demand. And extended flow is with respect to in which hour you have high or low demand. So steady state flow normally we do when we are running 24 means when you have like you have designed your system like say what you can do is when it's intermittent supply. So for only during let's say it's one time intermittent supply. So that's the flow that you have taken here. Sorry. So that's the demand that you have. This is the total demand. And if you want to do that in one supply, so you can run a steady state meeting this demand. Or if it's intermittent supply, like say, if you are running a continuous supply, so you will do the extended hydraulic simulation. And in the extended hydraulic simulation, then in that case, what you can do is you just multiply it by, let's say, 3 times. Generally, the peak factor is 3. So you can also see the multiplier that you have given here is approximately 3, the maximum. So if you will design your network with a multiplier of 3, means whatever the flow that you have given, multiply by 3, then your pipe will be adequate to carry the water in your network. So is this clear? Should I repeat this? Hello? Hello?
Clear, sir.
Clear, na? If you are doing steady state simulation, then you will run it with peak factor of 3, so that you design for the maximum flow. So, or for that matter, you can see from the pattern, you can design for the maximum multiplier from here. You can also, if you want to see, you can also redistribute, and then you can see this is the multiplier that you apply. So in general, peak factor of 3 you can take if you don't have this pattern curve with you. So both, but doesn't matter whether you are running for 2.6 peak factor or 3. It's a minor change. But if you design for the peak factor, then you will not get this error of this head loss. So this is about pressure dependent flow, and this is just showing you how much percentage of demand you met with if that required pressure is going down. So required pressure is very much going down. So obviously you are not able to meet the demand, the 100% demand of that node. So that will, so you are the demand was this much, this blue curve, and the red is what demand you were able to make with for that area. So this pipe is under designed. Is this clear?
Yes, sir.
Yes, sir.
Okay. So let's go to the next topic, that is on the map. Let's say this supply means here you don't have any head available, and you want to pump the water into this system. Okay, so instead of having this this head available with you are going to pump the water. So to pump the water, what you need to do is, first I will show you separately, is I go to this WD network, and then I select pump. Now pump will be between two nodes. Means you pump the water from source to certain network. So you need to create a link between. You need to create a link between two junctions. So this is one junction and this is another junction, and then you go to pump, and then if you are pumping water from here to here, so you will create a pump from here, and this is the symbol of the pump that is defined here in the layers and symbol. If you will go.
And what is this between these two junction, pipe or rising main? What is this?
This is rising main.
Okay.
Yes, you are pumping the water from here, this location to this location. So pump in mic plus is a link. Means you can calculate in the link, you can calculate the discharge. In junction, you can calculate the head or water level. So means if it's a collection system, then you are at node you are calculating the water level, and in the pipe you are calculating the discharge. So it's Q and H relation. So Q is calculated in the pipe. So this is a Q point. Pump is a Q point. So that's why it is represented as a link. So what I need to do is either from this point to this point, or what I can do is I can delete this pipe and this pipe, and then what I can do is I can introduce two junction or one junction here and one junction here, and then I will go pump, and then I will create from this source to pump here, and then I will also create from here to this point. So I have created 2 points, and then let me remove the result so that you don't get confused. And from this, so it goes into the, this is right, this, now from here your this pressure pipe is starting. So then I will go to pipe, and from here and then from here. Is this clear with everyone?
Yes, sir.
Yes, sir.
Okay. Also there may be a case where in the network somewhere, if it's a long, a big network something, and you are not able to maintain the pressure from the pump here, so you apply a booster pump in between, and then in that case also you can do is just delete any pipe here, and you can introduce a pump. Sorry. So you can, what I'm trying to say is you can apply pump in between also. Not only at the start mode only you can apply the pump. A pump can be from the source, if you have a source and then you apply to ESR, so you can apply a pump. So let me explain this again. So let's say you have a head here, ESR here, and you have a sump here, and you want to pump the water to this. So if you are pumping water here, so I apply a pump here. I can have a case where this is my network here, and I can directly pump through this pressure pipe here. I can have a so this is one of the system. Let's say this is 24/7 supply, and this is intermittent supply. Why I am writing here intermittent is what we normally do is, especially means if you will go to this villages and town. I have already explained this, but just I will repeat it again. If you will go to this villages or other area, you don't have 24/7 water, electricity supply in that area. Maybe in some area electricity will be there for a few hours only. So you would like to, supply this water into this into the ESR during that time when you have this electricity. So you create, and then it takes only few hours to pump the water from your source to the ESR, and then we have already discussed the ESR, and then you supply it here. So the consideration is you don't have the requirement of 24/7 supply, and that's why you have this intermittent supply, where you have we also discussed about you maybe have certain land topography or something, we are putting maybe the cost is not cost effective because you will have to put lots of ESR because of a certain area high, certain low, field again high, highland. So there you go for 24/7 supply. Obviously, the maintenance cost here will be very high. So if you have, which nowadays is getting more possible, like if you have a continuous supply system in your project area, in that case, instead of making this intermittent, because the problem is here is in the intermittent supply is you have to design a very big ESR here, because you need to make a more capacity of the ESR to store all the water that is required in this area. And if it is 2 hours, then a little, if 2 times supply, then little less, lesser size, but still it will be much bigger than. So what actually you are doing is, if your demand is like this, then what you are doing is you are supplying to this the whole this volume. Basically you are supplying during this period into your ESR, and then you use this gravity flow to supply into this. But if you have, like, say 24/7 supply, electricity supply in your system, then you can have this smaller ESR, a small size ESR here, and what you can do is you can make it supply here. So you need not run it for 24 hours. It again depends, like say if you have let's say 12 hours of supply. So what you need to do is you will have a ESR here, and you will have let's say a supply, maybe a supply like this, 0, and then you have supply like this, then ignore this, and then you have supply like this. I don't know, something like this. That means for few hours it's closed, and for other hours you are running this this pump. So you will keep filling this for some time in between. So pump, you will run the pump. In that case, you need a small storage, not the full storage if you are running it for 24. So 12 hour. So if that this, you know the size and you know the pump capacity. So let's say for a given flow rate, you have the total demand, you have the flow rate, sorry, you have the hours of supply, then you can get the flow rate, how much flow rate you need, and accordingly you can get the capacity pump that you need for this area. So in that case, what you need to do is, because there will be a means many times there will be a release from this, and then also supply into the system. So you will create a balance curve. So you have a time here, and then you will have a discharge out. You will have discharge in. Discharge in means pump. You are pumping, and then you will have the delta S net storage here, and then discharge you have from the you have the flow rate that with the multiplier, you know the discharge that you need, the total discharge with the flow rate. So if total discharge requirement is 20 liter, and the flow and sometimes 0.53, so you have a discharge outflow that will be happening from here. And whenever you are running your pump, maybe 5 hours in the morning, 5 hours in the evening, then in that period you will be having discharge into the system. So when you start with a certain level, initial level, and then discharge out will be removing the water, discharge in you will be putting the water, and delta S you can calculate from here. And this way, using this balancing, you can maintain the this water in this system. So whether you are means this is regarding pumping into the ESR and releasing. But also if it's whether you are doing this or this, everywhere you can apply the pump. So pump, it can be of various type. It could be a constant flow pump. It could be a constant speed pump, or it could be a variable speed pump in case of mic plus software. Constant flow pump means a flow is constant based on the horsepower. It has a constant flow. Constant speed is based on RPM, but it does not necessarily that constant speed has constant flow also. It is somewhat say if it is Q and this is it could be based on delta H if it's like say you have a wet well and you have a pump here, and then you have minimum water level and minimum water level and maximum water level. And if it is this change in this controls the flow this here. So in that case it is a variable pump. So here you have a based on H or let's say other example is if you have to pump from here to here. Second case, if you have to pump from here to here, so different H you are pumping, so you will have different flow rate. So if H is negligible, very small, then you will have maximum Q. If this H or change in H is higher, so you will have a smallest Q. So this basically means depending on how much height you want to pump, it will have a different flow rate for different height of the pump, this different DH value. So this is a even the speed is constant here. The RPM, the pump speed is constant. You can have a QH curve with this. In case of variable speed, it depends. You have not only this, but you have like this. So this is a maximum Q, and you have a minimum Q. So depending on what is the like if it's in the if it's a wet pump, then what will be the level, and based on that this value can change. It will be in between this and this curve. So that is variable speed. So the RPM will change for different set point. So we can model all these three types of pump. What I need to do is just go here, just go to this setup and go to this. Let me delete this.
Manish sir, sorry to
Yes.
interrupt you. Can we have a 10 minutes break at 3:45?
We will break at 4.
Okay, okay. Thank you, sir.
So I created now 2 more pipes, so I need to give the elevation. Just a minute. Let me check. So here I need to give. Let's say both of this is 70 meter. Or let's say both of this is 85 meter, or let's say 90 meter. So these two, I'm just creating an imaginary this thing here, and the tank, I will give it like 82 volt. Say 80, so 82 volt. That is the elevation, base elevation. Means I'm not giving any height here, and just to show you, and then I go here, and yeah, and in the junction I have given here. I go here, pump. Now I have 3 pump. I don't know why. Okay, I have also introduced a pump in the network also, just to show you. Map. Let's work with this pump only. Let's remove this pump and then I could have simply done is Control Z, Control Z, Control Z, and it would have taken it there also. But that's not the problem. I can delete it again, and I can give the dia 150. So all this is 150. So 3 pipes I have created new pipe. You can see here this pipe from here to here, this pipe and this pipe. This I have not given this. This is not a pipe. So this dia is not given. I have given the pipe this and this. Okay. So let's see the pipe. I also need to give the roughness. So on that page. Okay, so go to map. Yes, so I have only 2 pump now, and both is the screen. Then I go to pump. So I have 2 pump. One is tank to this junction 45, and another is junction tank to junction 38. And here you can see I have constant speed pump and variable speed pump. If it's constant speed pump and curve type is also constant, that means it's a constant flow pump. If it's curve 1 point, 3 point, or 2 point, so then it's so this is the curve. This is the QH. So for 20 meter head, flow rate is 10 liter per second. So you can see 20 meter flow rate is 10 liter per second. So that means normally this type of means when it means the this type of curve is provided by the manufacturer only, but you get this value here. You can have a 1-point curve or you can have a 3-point curve. So 3-point curve is you can define the sort of head. Sort of head is like, say, if you want to pump a water to to this elevation, you can pump. But if you want to pump this water, you can also use the same pump to pump up to this level. But if you want to pump up to this level, then you will not be able to pump that water there. So the elevation where you are not able to pump the water up to that level, that is your setup. So if it's, that means you can see here, so where your discharge is 0, so that is your setup head. So I can give it like, say, 30 meter. If it's, let's say, setup head is 30 meter.
What is that head when we close the pump and that last thrust water gets, right?
Sorry,
Sir, I thought that shut off head was the head when we close the pump, water takes the last thrust, which is more than the head which we require. Like it usually gets a last thrust when the pump is closed. So that head is, I guess, shut off head. Can you hear me, sir?
Yes, I can hear you. So this is defined, means you can define that way also, but how it is defined in Mike Plus, that I'm explaining. So that can be means I don't know, maybe some module, some model software that you might be using. It depends how the system has been defined, how this particular component has been defined in the model, the module, the software. So yeah, which software means you are referring to when you define this?
No, sir, not shut off head is not something software specific. It's a characteristic of a pump. So if we are defining the pump, no matter in what software, it doesn't matter, because shut off head is a characteristic of the pump. When we close the pump, when we usually close the pump, we see that the water gets a last thrust before closing that down. The water goes a little bit more distance than usual. So that is the definition of shut off head. So it is generally higher than what design head which we are keeping.
Yeah, I will have to check. Means it's the means the thing is same, but defined in a different way. So I will have to I will have
Okay,
to
sir.
check this. So I will come back to this on this to you. Just give me some time. So I will refer back to manual, and then I will come back to you. You can also go to this manual and have a look. And have a look here. Just a minute. Okay, I will come back to on this to you. But anyway, even if that is how it is defined, how you will define, then also it's basically you will have a zero flow at this setup here. So here right now, if you say this 20, can you see this curve? So if at Q is zero at head of this, it's more than 25. Let's say, let me put it some value. Okay. This curve you will get from the manufacturer itself, but anyway, just let me have a look. Otherwise, I don't want to explain something wrong. Just wait. Let me.
So what he's saying is correct. Generally, the shutoff head is 15 to 20% more than the design head.
Yes, it is more than the design head, and just the explanation component means both are talking the same thing, but it is different. How it is explained is little different. So just it will be better for both of us.
Can't we search it, sir?
Yes, you can also search it. Network editor. You can also search it. Standard public no extended flow range. Cutoff head is 133% of the design here. How the setup rate is the head value at zero flow. So yeah, it's the means, maybe the definition is little different, but I think we both are talking the same thing. Okay. So the whole idea is we will not be able to pump up to that level. So if the level is high, means this your discharge, your flow is zero at that level. So normally, if you are considering this one point, by default, it's whatever the value you are defining here, it's 133% of this head. That is 30. You can calculate it. It's something around 30% is 6. So it's approximately around 26 or 27 meter. That is 33% of 20 meter. That is the cutoff head. Cutoff head, we say setup head and cutoff head is the same thing. Means there will be no flow at that level. Is it clear? Hello?
Yes, sir, clear.
So by default, in this point, it is 33%, but you can also define that value as per your choice. So you can give this setup or cutoff head and design head. So which is more than this head. So 33% is already given. I have increased them. If you want to increase this head value, you have the choice. Similarly, you have design flow, and you have high-end flow. So if design flow is 10 liter per second, and means during the start or during and when you close this, however you want to define. But in case of your high flow condition, what will happen is your head will reduce, and that you can define it here. So this will be the high head, this will be your design head, and it will be little less than the design head in the 3-point curve method. In 1-point curve method, you only need to define these two values, and you can also provide a curve. So you once a H relation you create yourself, instead of you want this system to create, you can give a QH relation curve here directly. So I go to this curve, and then I can insert, and then here I can say pump QH relation, and I can give this any name, pump QH, whatever name you want to give, and then you insert. Sorry, I cannot give a space, that's why it's saying something somewhere. So you go and then insert, and you create a QH relation yourself. So whether you want and then when you will go here, you will get this pump QH relation. So I can give a curve myself. I can modify the curve to a different level, means with 3-point, or I can give a 1-point curve, or I can give a constant flow. Is this clear?
Yes.
So let's assume it's a 1-point curve here with CSP, constant speed pump. So like I said, constant speed can be a variable flow. So that this is defining the variable flow depending on the head configuration. If I will make constant, then it's a constant flow pump. So I just need to give the this watt kilowatt means horsepower pump. If I select same thing with variable speed, then you will see this gets highlighted. And in constant pump, this is unhighlighted. So when I will select a variable speed, then you will see you can control the flow with a remote mode control or downstream mode control. Any means if you want to control your flow with any consideration, let's say control the discharge of the pump with the given pressure. So let's go to the network, and let's say when this pressure is less than certain value, then it will increase the flow. The flow it will try to maintain the pressure here. So the speed will change to maintain the pressure here. So depending on this also, you can apply this variable speed based on certain control point and control. So you can apply a variable speed or a constant speed pump, and in that case, I can take this 1-point curve. Relative speed is when you are starting your pump. Okay, so it with the flow, there will be certain let's say 10%, 15%, or 20% more flow than the actual So you can apply the multiplier like this here. For the it is for the initial condition. So I have applied this pump 3, and here let's consider this only. How much flow was there? If you can remember, so I can give that. It was I think in pump 3, 5. Let me see map. This is pipe number. Just let me select this. This is pump number 3. So let me run it for flow of, let's say, 20 liter per second, and the head of, let's say, 30 liter. And this tank was having less flow, so for 10 liter. Now, once you have defined this, you can also use, because in real-time operation, you need to know the how much the cost will be there, and I can put speed here also. So you can define the cost and the cost pattern, means because when this changes, so you can have with a different RPM, different cost, or different horsepower, different cost. And then another component is efficiency of the curve. Efficiency is again something like this. A curve something like will be this. So you have highest efficiency. So this is the for a different Q and different H, you will have, your efficiency will change. So that is also provided by the manufacturer only. So different this pump will have different efficiency, and when you are up for a particular discharge to a particular head, you will have the highest efficiency, and after and before it will the efficiency will increase. So that efficiency curve you can also provide, and based on that efficiency and the price, you will get the actual power consumption that is required and the cost of the consumption. You can also apply regulation, where you can say that okay, if you can apply load condition, means if you are running every day, like say for 2 hours, so you can give that time. If you are running based on certain control level or certain control node or control level, you can provide that this value. So other time it will be closed, and only this time it will be open. So in real-time control, you can apply these descriptions. So this way, I have given a simple pump detail here. In this case, so now I need to let's give this value some pattern and value here. Let me see. With this I can create. Let's see if I can use any of this. You can also create any pattern which you want, just for the purposes. So what we will do is, just we will break for 10 minutes, and then we can continue with this you know pump design. So let's meet at 4:10, everyone.
Yes, sir.
Yes, sir.
Okay, okay. So we will meet at 4:10. Hello. Can we start?
Yes, sir.
Yes, sir.
So let me share my screen again. Okay, so we were working on the pump. So so we have given this detail here, and then we have selected two pump from tank to this junction before lunch, and then what we need to do is we need to give the efficiency of the pump, and also you can give the price pattern and the cost, everything you can provide here. But whatever you will click here, that any curve, anywhere which you, the pattern that you are following here, you can create in this curve and widgets here, or in pattern. That is the table that has this loss coefficient, curve relation, and pattern. So curve we have created for this QH, Q versus H curve. Like you can give it this discharge 0. You have head of let's say 50 meter. I don't remember exactly, but 5, 50 meter, 20 meter, 50 meter. Liter, 20 meter, something like that. Just delete this point. One more point. Say for 40 meter, something like that. 20 meter. You can make it more point to make it proper. This way you can create a QH place. Similarly, if you will insert again, you will see that you have, you can create this curve for pump efficiency for pump QH curve, then price, pump torque, for valve operation schedule. So let's develop for even a valve head loss. So let's select this pump efficiency and name this pump efficiency. And then here I will introduce insert, and let's say for 5 liter per second you have efficiency of 20%. For 10 liter you have an efficiency of say 50%. For I think it was 20 liter. For 20 liter you have an efficiency of let's say 85%. Then for 30 liter, you have efficiency of 60%. And for 40 liter, you have efficiency of 50% or something. So you can create a curve like this. Efficiency curve. It will be smoother, but it will be like this. You will be having for a certain Q, you will be having the highest efficiency. This is also provided by the manufacturer. So so this type of pump efficiency you can provide in the, and once you provide this pump efficiency, what you need to do is just go to this pump properties and just you see the pump efficiency automatically will come here and you can provide like this. So once you have provided this pump efficiency, similarly you you need to define for you can have pump efficiency 1 and pump efficiency 2 also. Here this is 1 point. Yes, this is then 45. Yes, then energy. I have given the pump efficiency. Just a minute. Just sometimes it gets hanged and it's not updated. Here actually it's selecting the table and selecting the table. Here you have this 1 point. You can see, and then energy we have provided. Let's say same efficiency for both this pump. Then you can also provide the regulation, like I have already told you, explain you. I have I explained this regulation. Hello, anyone?
Maybe you can repeat, sir, quickly.
Okay. So it's just what you need to do is open the control, and then you can say that okay, when my let's say I want to run the pump only at a given time, or if my node is above any node you can select, and then say that when that node level is more than this or less than this, above or below certain point. You can also define the value here. So this way you can give the control that if it is automated kind of thing, then you can provide that okay, when you want to start the pump and when you want to close the pump, or you provide a constant time here. So at this time, at a given time, you just open or close the pump. So you can provide this time and with AM PM when you want to start the pump. So all this is real time control, means a real time regulation. But right now I will, and then if I will go with here water hammer analysis, then I will get this also activated to do this water hammer analysis. I will come to this at the end. So let me let so energy regulation I have removed. What happened? Something happened. I don't know what happened. Check again. I think I have given everything. Yes. Why this tank is not coming? I deleted that. sometimes if you get an error like this, just you need to close your map and then restart again. Sometimes it happens. Or if you will run the simulation, it will not give you an error. Just wait. Open that again. So today we start with, we have not made the day 3, but it's fine. So you see, sometimes you get a warning here, but it's not the actual warning. So have everyone done this same thing in your model? Just do the same exercise in your model quickly. What you need to do is just go to pump. First go to map and delete this connection from this tank, either one side or the other side. You can create both sides, and just connect from tank to this node that I have created, and give the elevation of this node to let's say 90 meter, and this pipe dia 150 meter and this pipe dia 150 meter. Hello everyone, have you done this exercise? Anyone?
Yes, sir.
Okay, you have already done
We are doing,
this.
sir.
Okay, please do that. And once you have done this, then you need to go to click on the pump, and then you will get 2 pump option here. The connections will be there. Just select your CSP here. Give the relative speed to 1.2. Make this curve point 1 point and get this at 30 and 20 liter per second. Just simple. And then provide the pump efficiency. So to provide the pump efficiency, you will have to create a efficiency curve. So to create an efficiency curve, go to table, go to curve and relation, and click on insert. And give this, let's say, pump efficiency, just, or say PE, pump efficiency 1. And in this pump efficiency, what consideration that you need to make is you will have a curve like this. That means at 0 flow, obviously you will have 0 efficiency. You will have some maximum efficiency at Q, let's say it's 20 liter per second. And then as you go further, this efficiency will decrease. So this efficiency curve, so simply what I made is here say 5 liter pay, you can start with zero also. It's like a zero pay, you have zero efficiency, 5 liter pay, you have 20% efficiency, 10 liter means liter per second, you have accordingly just in the middle you have high efficiency and then you have low efficiency. That is the normal efficiency curve that you receive from manufacturer. So everyone has created this pump efficiency.
Yes, sir.
Okay. So so only this much is the minimum requirement for the pump is you provide the curve, this head versus Q curve, SQ curve, which you get from the manufacturer, or in general, whatever the or you can create by 3-point or table by yourself. I have also given, if you are creating from table, then it will ask you to provide the curve efficiency table, and that also you can provide from this curve and relation. So if you will insert, then you will get here pump QH curve. So you can create a pump QH curve also. And if you will create a pump QH curve, then you will get the option here to connect to that pump QH curve. So if you will click here, then you will get this pump QH curve pointable that you have created there. So I hope it is clear with everyone. If you have done this, let's say just you can run it. So and the details on the map. Let's see. Different here.
Excuse me, sir.
Yes.
Sir, so we are considering these pumps as online pumps running continuously, right, sir?
Yes, here, but means for the simulation period, yes, continuously, and to yes, and to run it for a specific period, what you need to do is you need to go to regulation, and then you need to say at when you want to run your simulation. This pump.
Yes, sir. So when we are running the pumps continuously, don't we need to adjust the details of the ESR?
Yes,
because
yes, yes. I have already what you said, the what is the see,
service reservoir. Yes.
Yes, yes. So you see base elevation. Means for this case, I just assume that okay, it's 24/7 supply, and there's no HGL. You see that it's on the ground only. Base elevation and reservoir property is the same with this big HGL.
Okay, sir. Okay.
So that's yeah, and it doesn't matter, means I can because in this case I am not to put a pump from source to the tank. I have put a from the I have considered this like a source, from this I am directly pumping into the system. Got my point?
Yes, sir. Yes, sir.
So obviously you see you are getting a high because it's means I have not scheduled the time, so you see that high pressure. Earlier it was something around 20 meter. Here now you have 36 meter something. Head. Here you are very high head because of this the pumping which I am doing here. So this is about the pump. And then again, if it's high head, then you can go with less horsepower pump, or you can run it for a specific period. You can modify as per your choice. Because if you want to maintain a head, because everywhere I'm getting more than 30 meter of head. If you want in the 20 meter range, you can reduce the pump capacity. Or you can run for a smaller period. If you are putting the water in a storage tank, and then you are releasing from there, if that is the case. Okay, so again, what changes I made? So because it's showing. Okay, here I said. Again, you see, sometimes there is refresh issue, so you get, but there is no problem here. It has run successfully. So everyone is able to run the model.
Yes, sir.
Yes, sir.
Okay. So if you are able to run your model, then okay. So let's discuss some more component, and then I will come to wall. Okay, because when we will discuss wall, then we will also discuss this water hammer component. Okay, so in the end we will take up this water hammer component. So let's quickly see some of the component that we have list, and some of the special analysis, and then we will come back to this water hammer component.
Sir, valves.
Yes, that's what I'm saying. This wall we will take with water hammer, because
Okay.
means this is both is linked. Okay, so how you control, means how you manage water hammer, or prevent water hammer is when we will discuss this wall, then we will discuss that. Okay, so this two we will take at the end. Is this okay?
Okay, sir.
Yeah. Okay.
So we will just we have missed some of the, means till now whatever we have discussed, means in general we have discussed pump and the network, and we have missed some of the component which we will first cover, and then come back to this wall and water hammer. That will complete the complete our training program. Okay, so let's go to this first zone. So here, what we have decided, the model that we have created here. We have just created a small with a single zone, with a single this zone. Here, what we can do is we can have a different zone for different area. There is an option here, zone mapping. You can also map your zone based on your valve and pump, different types of valves and pump, closed link, and you can also save zone into various categories. So this is right now I have only two pump here, nothing else. So if I say, let's say I want to, you can give any name, A, B, C, D, whatever you want to give here. So it will save zone in that name. So if I say here, let's say A, and if I run it, it will create zone, but it would have been made more logic. Then I have different valves here, and different locations. Then it would have created multiple zones. But right now, all is in the same zone, because I don't have segregation here. Otherwise, it is one of the way to create the zone mapping. Another is, if you will go here, so it has created some zone, but you can also insert from here a zone. So let me delete this. And then if you see zone, then you have different type. You can divide your zone as a DMA zone, pressure zone, demand zone, region. You can divide on the basis of word wise, or you can any nomenclature other that you want to provide. But let's say it's I'm doing it DMA zone, and then I have this population range. Means in that zone how much population is there, I can write, and how much demand is there. So let's say in this population there are 5,000 population, and 20 liter per second, or 10 or 5 liter per second demand, or 10 liter per second demand. You can calculate it with as per that one at the end. Then this coding is based on what type of zone that you are selecting. So a DMA zone is 0 by default. It is there. If it's a pressure zone, then 1, then demand zone 2, 3, 4. So accordingly, you can give this range here. So it's 0 range that so that you can define it here accordingly. So if you have selected here 1, then you should write zone underscore 1. So you can select like this, 0, and you give this. You can write something if you want to write something. You want to write. You can write something about this. Now, what happens is,
Sir, what does it contain? Zone 0, zone range.
right now it's not containing anything. So we will make them contain something. It's just that if you are selecting DMA zone, then
Sir, DMA zone consists what? I mean, it is based on, I guess, meter, district meter.
yes.
So we have not installed any meter yet.
That's fine. Still you can give this the nomenclature. It doesn't matter, because ultimately you are giving this total detail here. You can divide on pressure zone also. You can divide on the right now I'm just explaining you the component. Let's say if you are saying, like, say if you are dividing on demand zone, then it should be demand underscore 3. For that means first you need to create here zone mapping based on this demand zone. So it's taking other zone type. So replacement issue is there. Zone 3 is not defined. I have not defined the zone 3, so I will have to define the zone 3. So okay, I will define that later. First try to understand things, see how it is done. We will come to this zone range later. How it is done is, you go to the map, and one of the option is you import a polygon file. So you have a polygon of district map, you have a polygon of a particular or area, or you can create a simple polygon just dividing, like say you want to decide this area is zone 1 and this area is zone 2. So I will just create a polygon shape file, in GIS and bring it here, and then I will go to this zone, and then and then if I will go to this generate, so it will ask GIS layer. So I will just give the link of that GIS layer which I want to add here, and I can divide this as a, and I will say apply, and that will be divided into that zone. So it can be based on GIS layer, or I can do is zone IDs from the pipe properties.
So can you please show us on the basis of DMA?
If it is a DMA, see zone type, any zone type that you are doing, if it is the basis of DMA, then you will need like whatever the this, still you can do the same thing. Let me show you. Still you can do the same thing, generate, and then it is you who will create this polygon layer. Means based on this map, you will create a polygon file. Whatever the zone type you select here, irrespective of that, whether it's based on district meter or based on whatever, you have a choice that you can create a polygon, and whatever the polygon that you are selecting here, it will convert that, and then you can define it here that okay, this polygon layer is this DMA. So here I can create a polygon layer shape file, and then I can define it as a zone type DMA, and or I can define it as a demand zone or any region zone or what, any type I can define. So whether it's DMA or any other zone, I can define it as with my polygon layer, which I can do it myself. Is this clear till now? Hello.
Clear, sir.
Then if you don't have GIS layer, also you can do is you can just zone ID from pipe properties. You can say like I can select I can select here in my and then yes, pipe is also selected. Zone, and then I go to generate, and then I say zone ID from pipe, and then again I select from here, and then any description you want to say, you can apply that description, and then you say apply. So that means, yeah, so whether so this way you can create a the zone, and in this case it will be and if you want to insert, and then you will go to zone 2, and then again you will go to generate zone ID, and go to map, sorry, first go to map, and then invert selection, so other layer that you are selecting, and then go to zone and generate zone ID, and then delete it is also zone 0 only, that is DMA zone, and you can do a different population and different demand for that. So this way you can also do the zoning of your project area. If I would have given this some wall here, somewhere in between. So based on this valve also, it could have created, a separate zone for based on this separator. So this way you can create two zone and you can define different population for this zone. And when you will define this two zone, the only matter is wherever you will go. Let's say you go to distributed demand, so you will have two zone here, and you can give different demand for that. And then if you will apply this formula, then for that zone, it will be more refined one. Means you have divided the total demand into two parts. So I can use this or I can use this formula also. So everywhere, wherever you means you are applying the formula, you can apply the formula based on this zone. You can even the simplification. It's a selection, but you can select a particular zone and then you can apply the selection here. What you can do is what we do normally. What we do is when I go to this, let me go to the map. I also wanted to show you. This is the selection manager, and in the selection manager, you see zone 0 have all this 5 list. So what we do is we add selection here. Let's say you can create, and let's say here I say edit selection, not edit. Let's say add, and say, let's say whatever the name you want to give here. Let's say zone 1, and or let me delete both this. Say add selection, rename, and let's say it is zone underscore 1, whatever the name that you want to give. And I say update from map. So all the selected layers will automatically be inputted here. So I say update from map. So you see all the junction point, all the pipe point, whatever that is selected here, it has come here zone 1. Then I go to add selection, and then I go, let's say rename this to zone underscore 2. Normally we put the zoning based on whether it's 1, 2, 3, 4 means DMA or whatever. So you can write a code accordingly. Let's say it's for your reference only, but this is how we follow. So zone 0 if it's DMA, and say part 1 DMA 0, and then second part, and then I say on the map, first what I will do is I will say invert selection, means all other components. So it has selected another component, and then I will say update from map. So this is my this pipe 12 is in zone 1, and pipe 11 is in zone 2. So this way you can divide your area into 2 zones. So if I have this, if I have created like 2 selection manager here, it will always be here. And then if I will go to this zoning, and then I will go here, this zone 1, I will select this first, and this I will select, and then here I will give 5,000 population, and here I will give, I don't know, let's say 8,000 population. Here demand is say 20 liter per second, and here demand is say 10 liter per second. Is this clear with everyone? Can you quickly do the same thing in your model?
Yes, sir.
So this is one of the option. And then if you have done this thing, if you have done this thing, then you need to recalculate the demand, distributed demand again, based on otherwise, even if you are doing this, you are not actually giving the this demand to your model. You are giving the demand that is available here in multiple demand. So what you can do is you can apply this distributed demand based on this zone one. Just you need to select this and then give the pattern and category and then run the model and this compute. Is this clear? So
Yes, sir.
yeah, so I can you can go to this. Let's say I create a new. Let's say I create a residential and category is residential, and I click on this. So if I go to this multiple demand and category, you have this leakage residential, and then we will have more residential demand. The number might have as increased, you see, because it will create two residential. So right now it's having a problem that if you click replace, it's replacing the also the leakage, so you need to create it again for the both. But once it is resolved, then if you will override, it will override for this category only, not for all. So, but this is how you define this, and whatever that that is you define. If you will define it as a pressure zone, you see it's not here because in this zoning you have defined this as a DMA zone. So how you have defined this up to you. So I hope it is clear with everyone.
Yes, sir.
Sure.
Yes, sir.
In the selection manager, once you have taken the selected the items in the selection manager, you create another zone, and how do you add those points into that zone?
This is in what selection means all that is selected will be removed, and all that is means the other component will be selected. So in the right now it is selected. If I will click here, so this will get this actually gets highlighted and it is getting selected. If I will click here, this is getting highlighted. This is selected. It's just that this point is also selected somewhere, so that's why it's it is remaining here. Just I don't know, somewhere it's selected.
No, sir. What I was saying is, once you have selected all the points based on polygon selection, you click on the selection manager and add another zone.
Yes, add
zone.
selection. So here selection manager and add selection. If you will here click, you can write also here, or you can rename from here also, and you can write any, say, zone 1. I can give like this, and then if I will say update from map, so all the selected layer will come here. So it's not only that I need to click create this selection only for zoning. I can create selection for any other type also. Let's say I always want to see the analysis in this file. So what I will do is I will select this layer. So this I have selected, and then I will let me rename to say critical point. Critical, whatever. or if I want to see anything. So I go here critical and then I say update from map. So it has selected this point. Let's say I'm not interested in junction. So I will select this junction and then I will say delete item. So it's only pipe that is remaining here. So I have selected the pipe here. Now the good thing about is any time I want to I can nomenclature, because then it's a big identifying a particular part or area or node, it will be difficult in one go. So you can create a selection layer, and anytime let's say I unlike this, anytime I can go to this layer and then I can say transfer to map. So this, just let me remove this result file. Result file, yes. So even yeah. So you know I have selected this layer, and anytime I can go here, I can set flag here, and I can set flag here, and I just want to see the profile of this this line. So I can click here, draw profile, and I can get the elevation profile of this. This will make more sense when you are doing a collection system design. But just to get an idea of any, just I'm saying that you can make n number of selection layer, and zone is one of them. Am I clear?
Yes, sir.
Yeah. So this selection manager helps you work with a particular area, particular node, particular junction which you want to see again and again. So just highlight those and see the analysis of those layers at that time. Or if this is selected, you can apply anything diameter and anything which you want. Change in properties. You can apply the fish calculator directly to apply that. So this helps us, this selection manager. Any selection manager that you have created, it will be available if you are working with the zone. So you can create a new zone, and then just you can go generate, and you can generate it based on the layer or this thing. But if I will create this, I will have now I will have 3 lists. So I can select I should know which I have defined it as zone. So what name that I am giving is important, and this helps. This nomenclature you need to give such that you know that what it represents. And this way, so I know that this is my DMA zone for one area and second area. I can have a zoning for a pressure, zoning for district wise. I can create n number of layers and will apply only the layer which I want. So nomenclature, just keep it as so for as per your reference. And by default, if you will click this zone mapping, you can also create from here, but for that you need to have this all this component in your system. So I hope zoning is clear with everyone.
Yes, sir.
Sure. Any question in this? Anyone?
Yes, sir.
Okay. So once you have done this zoning component, we have already discussed about pressure dependent demand. Let's quickly do some specific analysis. Let's go to this module type, and let's do this first, this pipe criticality analysis. So if you are doing this pipe criticality analysis, you see when I click this pipe criticality, you have a special analysis options available here, and in this special analysis you have this pipe criticality option. So any module that you will select here, fire flow analysis, so you will have this option here. Flushing analysis, so you will have this option here. So let's understand this pipe criticality analysis. Let me
Sir, before we go ahead, can I ask a question about the last topic?
Yes, sure.
Sir, suppose we have created. I have
sorry, I can't hear you. Network problem. Can you repeat?
Yeah, sir. Suppose we have 3 zones in our system.
Yes.
And I have to check the flow rate, how much.
Yes.
Calculate. So do we have facilities to install the meters in the software?
Meter in the software. Sorry, just I think there is some network problem, but let me tell you what facility it has, and then I will come back to you. So whenever you create a zone, this zone mapping, this when you will run the simulation, this zone mapping will come, and then you can have a list. Normally, this comes when you are going from here, but this option will be when you will. Otherwise, if you will run the simulation with the different zone, this will be updated here. And then what you can do is you can see a particular zone, and then you can do a particular analysis in that zone. So this is about pressure dependent demand, which I have done last time. So and this is zone. So zoning is not showing completely here, but it will come here. Number one. Second is you can always export this layer, this selected zone layer. Let's say if I select a particular zone, then I can export the layer to zip file. I can import this layer, and I can you can put this layer in the background zip file, and you can analyze the result manually for that layer. There is no way here that you define means you can highlight this or highlighting. You can go here and then transfer to map, and then concentrate on the analysis here manually. If you are also what you can do is you can go to this demand allocation, and then you will go to this demand allocation, and then you will when you will add this demand here. So you can give this demand pattern that for each category. You can give there is residential, height, demand, and it is to nearest because your house will be not on the network. It will be alongside the network. So you will say like say this is about meter information. So house number, let's say address 112 by this Mayur Miyar, or whatever that address is. So I gave the address, and I gave the detail of this demand, and then if it is meter, so I will put a point here at this X and Y value, and then I will say they connect it to the nearest node. So what it will do is, if this is this node and you have this this house detail here at this location, so automatically it will get connected to this node for the demand. If you are using to nearest node, and you will say apply. So if I say, let's say if I say apply here, So it is applied to junction number 27. So this way I can connect it to nearest node, to nearest pipe, or I can give the pipe ID, connection. All this means this details I can create for all this ID. All area I can I can create this ID. So I will for each house I will have a coding, and if I have this X and Y value, I can copy paste from the X and Y value. So I will have the all details of houses, that means all details of meter, and then this it will be connected to that particular ID, and then you can apply this demand, the aggregate demand, because there are multiple houses will be connected to a particular node. So this way you can create the this you can compute the connected demand based on house information. So considering which house is connected to which node. Am I clear?
NRW?
Non-revenue water.
Yes.
Non-revenue water is a separate thing. We have a leakage monitor is another software. So if you will see, if I go here, you can monitor. If you go not here, it's a DHI. Just to show you, because it's an important thing, but we have a separate separate software for that.
So we don't do NRW in this Mic Plus.
No.
Okay.
We have a this leakage monitor.
Okay.
Let me show you leakage monitor. You can go through this app. It will give you an idea, and for that we have a training module separately to understand the leakage monitor, and it's a software. So it does analysis with respect to economy of water loss, which leakage you need to monitor, and you need to give more preference where you need to do the maintenance. So a detailed analysis you can do. The best means the base will be Mic Plus only, this system. So the modeling will be this system only. So this system is uploaded on Mic operation software. This is our DMS software, and they are using that this Mic Plus and Mic operation. This leakage monitor is this tool is developed. So that's a separate monitor. A detailed analysis you can use. You can do using this. You can maintain the low leakage, plan repair, reduce insurance cost, pressure optimization, illegal. You can identify illegal connections. So all this analysis you can do using leakage monitor. Base model will remain the same, but you need additional tool for that. That is the leakage monitor.
Okay. So sir, you also give the training on NRW?
Yes, but we have we have not given NRW training in India till now. So we will be planning a training in coming days, but till now this NRW is this is not that much popular in India. Outside India, this there are lots of training program being added. But
it is popular in metro cities, sir. Only.
Yes, nowadays see means Mic Plus software has been applied in many countries, but in India it's not that much popular. It's gaining popularity nowadays. So that's why we don't have any case study of NRW study in Indian scenario.
Sir, I guess we have in DJB, Delhi Jal Board, and one for Shillong.
No, with my plus, with my
Okay,
plus,
okay.
our software. That's, lots of test analysis has been done with NRW in India and outside India, but only I'm talking about our software.
Okay,
Yes.
okay.
So that's why we have not added any training program till now in Indian scenario. So we will be doing that in coming days. Okay, so this point is clear up to
Okay,
this
thank
point?
you, sir. Thank you, sir. Clear.
Okay. So this is so you can this is the best method to do the calculation because this is the detail based on the actual house connection. So this is the best method to do this, but obviously this is more time consuming and you will have to have the complete house list and everything detailed. This so what we can do is so that's why we apply other method of distributed demand calculation. Okay, so if it is clear, then let's go to the pipe criticality analysis. Now, when I say about pipe criticality, what do you I have a PPT. Okay, just a minute. I think at 5 p.m. Mani has Avilas has joined. No. Okay. So we have time.
Yeah. Abhilash is joining in like 2 minutes.
2 minutes, yeah. 2 minutes. He will be joining in 2 minutes.
Okay. So I just very quickly I will go through PPT. Let me show you a PPT. I don't know whether I. So basically, just to give you an idea, pipe criticality simply means. Let me go to this. Pipe criticality simply means that how important is that pipe in your network. Means what will happen even if you will remove this pipe. Your system is a loop network. So just try to understand here. If I will remove this pipe, let's say if I will remove this pipe, if I will remove this pipe, what will happen? This water to this area, to this node area, water will flow like this. So still this can get some water through this network. If I will remove this pipe, then the water will flow like this and this and this and this. So both of this pipe, let's say just take an example where I have a tank here.
Manish sir, sorry to interrupt you. Mr. Abhilash has joined. Welcome, Abhilash. And
just Miss Avilas, can you give me 5 more minutes? Then we will break for 10 minutes.
Okay, then I'll just leave the meeting. Once you are done, do let me know. Okay.
Yeah, just 5 more minutes. I just want to end what I have started. Okay. So this, let's say I create a pipe here. And then it goes in this direction, and then it goes in this direction, from here it moves to this direction, and then it continues. Okay. If I will remove this pipe, what will happen? There will be no supply into this network. Am I right?
Yes, sir.
Yes, sir.
That means it is the most critical pipe, right? So same way, if you will remove this pipe, or if you will remove this pipe, if you will remove this pipe, this whole area will be impacted. But if you will remove this pipe, only the area that is here is will be impacted. If I remove this pipe, so this area will be impacted. If I will remove this pipe or this pipe, the impact, even though it can receive water, but obviously the pressure will be totally different here. You will have less pressure here compared to when you connect it here and then you get a high pressure. Because in this case, the flow direction is like this. So you have more head loss from here to here. From here to here, you have less head loss. Am I? Is it fine till now?
Yes, sir.
So there are various factors on this this pipe criticality that is analyzed. We see basically the criticality of the pipe, the importance of the pipe with respect to demand, with respect to pressure, with respect to this select here, and then there are four types of consideration. One is this pressure, another is based on demand, and then based on I think the pipe is, means how old that pipe is. It is dependent on the pipe diameter. So the criticality of this pipe can be defined in on different types. So what this model does is it by default takes four concentration of this pipe to get the exact the criticality. Like why I'm saying here is it looks like both pipe is moving from here from here this direction and this direction. So but this pipe is carrying more discharge. We have already seen that this is 15 or 16 liter per second it was carrying, and it was 8 or 9 liter it was carrying. So in that sense, with respect to demand, it is more critical than this pipe. So also means, so with respect to demand, we can have a different criticality factor. With respect to pressure, we can have a different criticality factor. With if the pipe diameter means more the diameter, obviously it's carrying more water, and it's fulfilling to the the demand is met with in more means more demand is met with in that area. So it also based on the pipe diameter, and then there are other factors. Means the fourth is by default taken, and the fifth factor you can take any other criteria: roughness, length of the pipe, based on wall state or status of the pipe, wall thickness, inner diameter, anything that you can take at the fifth criteria. So what we do is to do a pipe criticality analysis. What you need to do is just select this pipe criticality and then say insert. And in this insert, what you need to do is you need to see how much minimum pressure that is required. Means it will do the calculation with respect to a certain pressure, because if what it does is one by one, it will remove one, like it will remove the pipe, this pipe, and it will run the model, and it will check what is the whether yeah, it is able to maintain the pressure, the full pressure or not, how it has impacted this with respect to when it was there. Then it will remove this pipe, then it will remove this pipe, and will run the model again, and will check the condition with respect to original condition. So one by one, it will remove the pipe, and it will see how much area is getting impacted with respect to how the flow and pattern, how this pressure is changing into the system with respect to the original, and accordingly it will give you the pipe criticality. So let's say if minimum service pressure is say 25 meter or 15 meter, whatever, and let's say I only want to do this analysis with the 4 criteria and select whole network. I can also do is I can select extended period simulation, and then if you are selecting extended period simulation, then it will every time it will do the calculation, or you can also select means a time level. Means if you are doing steady state simulation, then you don't need to select. I mean, say by default it will be a constant value. So if I select extended period simulation and then give the time, let's say I want to see the analysis at 8 a.m. Or 8 hours from this from the start of the simulation. Or I can use the steady state simulation, does not matter. Whatever the value, it does not take into account, because that will be a steady state simulation. And just whatever you select, and then you say this run simulation. You can run your simulation. Sorry. Am I running the model with? Oh, I have done lots of changes into the system, and all this is. So, okay. So, is Avilas here? Avilas, are you here?
No, sir, no, sir. I'll just ping him. He will be there.
Okay. Just let me know when he's here. In the meanwhile, I will just remove the whatever the extra I have created here.
Okay, yeah.
Okay, and this pump, I hope it's correct.
Mani, there are also, I think, few, maybe 21 participants. We had 24. Any update on that?
Yes, 2 of the participants, they have some commitments with their university, so they didn't join.
Okay.
It has run successfully. So
Sir, excuse me, sir.
Yes.
So Mr. Mayank, he has some problem with the connectivity in his area, so he is not able to join today.
Okay, thanks.
Okay, yeah.
Mayank is here.
Mayank Prashar.
Okay. So anyone having any problem means you can always refer back to this video recording. It will be shared with them, shared with everyone. So Avilas is here. Avilas, you can we can have a quick end session.
Hello.
We still have some topics left, and it will take at least 1 hour more to complete the topics, all topic. So we can have a quiz, quick comment or discussion with you, with the participant, and then I will continue with the training.
Abhilash, over to you,
Hello?
please. Yes, over to you.
Yeah.
Please
Oh,
address.
yeah.
Hello, we can hear you.
Yes, yes.
Yeah.
Just a minute.
Just let me stop sharing.
Hey, good evening. Can I see some faces?
Very good evening, Abhilash.
Good evening, sir.
Good evening,
Hi,
sir.
good evening.
So seems like you are exhausted for the after the 3 days training. How was it? Any feedback?
Good, sir.
Hello.
It's good.
Yes, yes, sir, it was good.
Yes.
It was a excellent session, and which will help to our career a lot. So this the sir helped me a lot with this mic place and explained very well. Okay.
So you are
So
from Mr. Harish? You are
this
from
was a great session. I am from Andhra, sir.
which
NIT
university?
Calicut.
Okay. Yeah.
NIT Calicut.
Okay.
So this was a great session.
Thank you.
Thank you.
Uh, Yeah, this is Preeti from Sweco. I want to just give you some feedback on the program, which the training which is going on. We basically are professionals. I would say we are working with a company and might be working in near future, might be working with DHI like softwares. So our actually requirement is quite different from what it's being taught in this training program. So we just wanted to have something, our expectation was quite different from what it's been, it's going on in this training. So just wanted to segregate the persons, because here in this MTech students and professionals all together sitting together, so we cannot interrupt and say that our requirement is quite different, so don't teach this, and we need this. And so basically I want to say that if it will be great if you can segregate the professionals and students, so that um, we can make this training more fruitful to us.
Thank you, Preeti. I understand. I understand your concern.
Yeah.
See, this is the open enrollment. We have two types of training. One is called the open enrollment, another is the DHI tailored course. So what I feel now is that you should have gone for the DHI tailored course. What is DHI tailored course is that the company like you have almost 4 people joining from Sweco, right? So in that case, it can be thoroughly for Sweco, and then you can decide which part you want to get trained. So here in the open enrollment, what we do is that we teach them the basics, and then it's not on the advanced type. So I understand it's a mix of normally when we do, if it was in offline, it may be on another way around, because you will be helping the students, and since this is one of the barrier. But I understand, since sometimes the trainer touch upon the basics or touch upon the concepts, since they are the MTech students. So for you, it's maybe I won't say the waste of time, but it may be like, oh no, this I would have been. I understand. So I really consider this, and then going forward, we will look into that, and we'll make sure if it is a group of large professionals, so we will segregate into another group or something. Definitely a valued comment, and yeah, we will look into it in the coming training.
I will ask, can I interrupt?
Yes, Manish.
To be fair to them also, what myself and Mani has also discussed, that we will have on Monday, if they have the time, we can have half day session, especially for them, so that all the whatever their expectation or the component, this we are not able to cover here. Some advanced stages we can give a specific time because they have already involved. It is also us who should have informed them that okay, this is the basic training. So if it's okay with them, we will have a dedicated half day specific training.
Yeah, because we want to make sure whoever has attended has gained knowledge. So Preeti, what will be your call on this? As we suggested, if you feel some of the points should be covered more or anything like that, please feel free to reach us. So as Manish said, we can give you a separate session for engineers from SWECO on Monday. Yeah, we are happy to do that.
I think I mean, I cannot say to you right now because we have other engagements with the projects and we have other commitments and, already planned our meetings and all. So I cannot say that, yes, you do that and we will, because this week I just requested them, the team will be on training and we cannot do the project work. But always, I mean, it's really difficult for us to say that again we want to engage the team for half day again. So it's really tough for me to decide right now, but I'll definitely come back to you on this, whether we can do, how we can do it in a bits and parts, or kind of like, I cannot promise you that Monday whole day or half day we can say yes to you, but we'll see and come back to you.
So
And
maybe
it's
I would
really
like to
great.
understand. Maybe I would like to understand where you feel like, because see, I know the agenda what we have shared during the training, we will be covering those points. Maybe something will be very basics, something will be hands-on. So I hope you have gone through the agenda of the training. So, but I would like to know where you feel that some more has to be, some more light has been thrown. So can you please put some points on that?
Um, Come again. What's exactly your question is, and then I'll come back.
The thing is that, see, we have already shared the agenda with you, with the 3 days training, what areas we will be covering. It's starting for, as you see the agenda, it's mainly starting from the scratch, okay, from the beginners. This training is mainly for the beginners. But understanding your point, I just want to understand, like, which area do you feel that we should have covered more?
Definitely the softer part, definitely, because
is it the hands-on training? Is it the hands-on
hands-on
part,
training, hands-on part basically, because the initial descriptions of the material or the technical understanding that we already know that we don't need to go in much detail, but I just wanted to know the software's complexity and what things can software do, these kind of things where we can apply our knowledge into exactly to best use the software. So hands-on, I would say.
Hands-on, yes. But is there any specific points or specific area you want to touch upon? Or maybe Manish, do you have any points to put here?
No, Miss, I think what she's saying is because first day and second day, it was more means we moved very slowly, making all the participants understand, and then we talked about we have given the idea of the interface, but it was not hands-on practice more. Today we had lots of hands-on practice, so maybe means what she's suggesting is we could have more hands-on practice from day one. Instead means what the idea that I have followed is once my network is ready, then we can do lots of hands-on exercise. So we concentrated all the theoretical, all the component while developing the network only, so that at the end it's quick, hands-on analysis for various components. So I hope you are referring to this only, Priti?
Sorry. Yeah, actually
Hello.
the software is really good, and understanding in detail is really required for us so that we can use it nicely, or up to the maximum, I would say.
Actually, I just wanted to add with Preeti. I am Mayank Agarwal and I'm working with Preeti.
Yeah.
Actually, here I just wanted to add like that in future also it's like general comment that we should not get ourselves indulged in such means like very small topics like population forecast and all those kind of thing, and there we have wasted a lot of time because everyone over present over here are IIT students and they are mostly are MTech students, and 90% of them knows what is basic population forecast and all those kind of stuff. So maybe our training could have started keeping all this thing in mind that we all know this kind of basics thing, and on top of that we are starting our training, and in between that if some kind of complexities came, then they trainer or the people inside the group can come up and say like this type of complexities can be solved by doing this kind of things. So that was not taken care, to be very frank. And secondly, I am going a little bit harsh, but this training was very unplanned. I am feeling this is very strongly on part of my team also. I can say that this training was very unplanned for at least for us, but I don't know about the rest, but this was really very unplanned.
Yes, Mike, here the thing is that as you can see, the majority is the students community. So for them, we have done mainly on the advanced level. So they always gave us a feedback. It will be really good if you can touch upon the concept, if you can touch upon the basics. So this, what we have put forward is putting those things, the feedbacks what we received from our many various trainings what we did earlier. And definitely we will look into this, and going forward we'll make sure the participants have the same wavelength so that we should not touch upon the basics. And here see, this is one of the challenge, I would say. If it was a classroom training, it will be definitely because we did this open enrollment in Delhi, and when it was classroom training, it's not only the trainer, the participants will also teach others, because we used to have the industrial people, we used to have the professors and the students. So we have seen with the interaction on another level. Now the problem is that since we all are like detached, or we are in a just online, and you know how difficult it is to communicate. And definitely we heard you, so we will be working on that. Any other comments?
Also
Sorry.
point well taken, and I will also try to modify my the training schedule as per your suggestions. So any other suggestions? All suggestions are welcome.
Sir, actually, sorry to interrupt. Actually, before coming to this program, I don't know anything about this mic place and all. But sir explained the basics very well. We came here to learn something about the mic place. Okay, so this 3 days program was somewhat wonderful to us because I don't know anything about the mic place. So I came to know about this thing, right? So sir explained very well, but don't know about the people who are experienced, who are very experienced with this software, but they don't have this opinion. But for us, like some MTech students, this was some good program.
Thank you, Harish. Thank you for your feedback.
Hi, this is Rajkumar.
Yes.
Yes, hi. I would like to say that, I mean, it depends on the expectations what people had. As per my expectations, I think it was very good. I learned a lot. It's been like more than 6 years. I am away from the basics. I'm into riverine flooding completely. So I'm kind of out of the pipe, pipe distribution, network distributions and stuff. So I am kind of away from those technicals. So it was very well brushed up, and I learned a lot of software, options and facilities. With the upcoming 30 days trial period and the tutorial models, whatever we have, I think I can get an overall good idea, and it might definitely help me in improving my future opportunities and scopes. And I would like to mention especially about Mr. Manishar. I think he's a very good teacher. I think he's teaching very nicely, and he's touching, and he's not even getting frustrated if someone is not understanding a concept. He's ready to explain it 3 times or even 4 times. uh, I'm happy to be a part of this session. Thank you,
So
everyone.
Rajkumar, you are from which university?
No, I'm from Risk Analytics, India.
It's
Oh,
consultant.
you
In
are
the
a
profession.
consultant.
Yes.
Thank you, Rajkumar. Yes, you said it. It's based on the expectation and again the level of understanding the participants has. So, yeah. Thank you for that comment.
Thank you, Abhilash. Thank you, Manishar.
Thank you. Thank you.
Any other feedback? Hello.
The floor is open.
Yeah.
There's any number of, there is nothing, there's no wrong, no right. You
Yes,
can be
yes.
as harsh as you want, as soft as you want, but we definitely like to hear the exact truth of of what's going on. That will help us to better ourselves and to to give quality trainings in the future as well.
See
So,
again the comments what from the people from Sweka has put forward. We take it as a constructive feedback. So yes, as James said, please feel free to reach to us because we have lined up many other online trainings, and this is not something what we do on a daily life. This is the only the second online training we did. So we know there is a lot of area where we have to improve. So your comments will really help us in improving the upcoming trainings.
Yeah, Vilas, that's what our Preeti's feedback was for. Actually, we felt a little bit. I have worked with WaterGem software firstly, so there were quite certain things which I thought that was not much needed for the some guys who are experienced. So we were just sharing that experience because we are compromising on our billing hours or like work project hours with this thing. So that's why it was just a honest. It was just an honest feedback.
I understand.
Yeah, so for
Yeah,
that purpose, because when you're working for a firm, time is of essence. We
Yes,
have to
yes.
be answerable to
Same
our
here in
bosses. Yeah,
DHI.
yeah,
Yeah,
so
you
the
have,
only
and
feedback
on
is
Friday you
because
have
of
to
that
put
thing.
you have to fill your timesheet.
Yeah, exactly.
And then it will
And
matters how much. Yeah.
And
See again.
regarding your
today is Friday evening and we need to fill our time sheets. Yeah.
Yes.
and sorry, regarding your
Yeah.
suggestion for this Monday half day session, yes, I think we will like to
See
study
again. Yeah. Please,
study
please
and go
go.
through the material once, and maybe we'll practice. So taking that time out of the project hours might need some few days. So just assure us that we can we in our team from Sweco will try to be on the same page, and we'll ask for you guys for one particular day, but it can be after 2 weeks also or after 3 weeks
No
also.
worries,
So
no worries,
yeah,
no
so
worries. Our
that
support
can
will be there. Yeah,
yeah,
no worries.
exactly.
Our support will be there. And maybe what we can do is that we can give you a 7 days extension license for you, so that you can practice it. And I hope the manuals are already there with you. And please work on it. And if you find any difficulties and if you want to get any more information regarding any tools, Manish and Mani is always there, so you can reach to them.
Yeah, because
Yeah.
our expectation was because of no hand-on practice on this software so that we can promote ourselves in getting projects. So for that purpose, we'll need some time, and this is going to be very important for us to go through this material or whatever material we have got. We'll consult it and we'll practice it like maybe in the next 3 weeks or 4 weeks, 1 or 1.5 hours per day or something
Yeah.
like that. But
Sure.
we'll definitely we will need your suggestions or guidance in future, like maybe this idea of half day session or 1 day session, we will need it maybe after some time.
Definitely. Anytime.
Yeah,
And maybe
thanks.
we can have a one-to-one call later next week. I just want to understand much more from you. So
Yeah,
maybe
sure.
James, if we can arrange a short meeting with Sweco, just want to understand
yeah,
the projects
we'll do
and
that.
how
We'll
we
do
can
that.
support them. Yeah.
We'll do that.
Sure. Thanks, Abhilash.
Any
So I
further
think
comment?
I know it's already, so I'm not taking much of the time. So I hope, James, you'll be sharing the feedback form. So
Yes, we
please
will.
feel free to put your comments over there. I'll be going through it on each feedbacks. And definitely, as I said, these are the points which will help us in developing ourselves to be giving a good training in the coming days. So with that, thank you all for your time, and I hope, yes, at least you learned something on MicroQuest and on the water distribution and things. So my email ID is abj@dhigroup.com. Maybe you can write it here, just a minute, so that if anyone wants to reach to me, please feel free to reach me, abj@dhi.com. So this is my email address. So if anyone wants to reach to me, please feel free to reach me. So with that, take care, stay safe, and happy weekend. Bye for
Thank
now.
you, Abhilash. Thank you. Thank you. Bye-bye.
Thank you, Abhilash. Bye.
Yes, Manisha, maybe we can resume. I think he's not there in the meeting. Yes, he's there. Manisha, am I audible? Can you hear me?
Yeah, you're audible, man. You're audible. I think Manish sir is muted.
Hello, can you hear me now?
Yeah.
Yes,
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 Manish.
very fine,
Ji.
sir.
Sorry. I was muted. So let me share my screen. Okay. So before this discussion, what we did was we discussed about this pipe criticality, and then with this minimum pressure, I have run this from here. You know, to run a special analysis individually, you run your this for that analysis. You need not run your simulation from here. So I run my simulation from here. It was the run was successful before that internship, before this break. So once you simulate this, the result will be automatically uploaded, because here what you need is which pipe is more critical and which pipe is less critical. So that will be that result will automatically, wherever you have this this file, you will see this is the log file that is created, and you also have this CSV file that is created. So if I will go here in the layers and symbol, tank, okay. So here, though it's not here, what you can do is you just click on the report, and this is created. Just I have shown you automatically. This day 21 base is created here. Let me delete this and then run it again, so that you can see again. Okay, I delete all this point, also this point. It's this file is in use, so that I cannot, because this is when you create it here. So I have created this, and then I will run it again. So I have deleted, just a minute. So I will delete this, and then I will insert this, and then here I give this 25 meter, and then when you insert this, you can see here this 2 file is created, and then if I run it, I hope it runs. Oh, I sorry, I deleted this or something else, but anyway, you can see this pipe criticality CSV file is uploaded here automatically. This I wanted to see, which I was not able to see before. And when you click on the report, it will automatically generate a report for you. And this result you need to analyze. Just let me do one thing is you can increase the size from here, and then just you see pipe ID, it's giving you here. Then discharge, criticality percentage based on discharge. This is your criticality percent based on how many nodes it's serving to, based on demand, based on length. And at the end, you have this criticality percent. So what you can do is, you will get the same report here. You will get the same report here. You can open this in Excel and yeah, Excel. Just wait. No, not this Excel. It has not opened. Just wait. Go here and then day 2 and then open with Excel. Yeah. And then here just you can apply this filter. I don't know, my system is getting a little slower, it's hanging. So but you can apply here smallest to largest, or say better largest to smallest. So you see, this is with respect to discharge, this is your most critical pipe, and this is your second most critical pipe. So let's see pipe 23 and pipe 11. I just, you can go to your pipe. Let me close some of the window here. So pipe 23 and pipe 11. This is pipe 23 and pipe 11. So this pipe, it's saying, is the most critical pipe in my network based on discharge, because it's carrying 16, then 15, then 14 something. So it has giving me the this critical list here. Similarly, based on how many nodes it's serving to, which is more critical and which is less critical pipe, you can see from here. Similarly, based on the based on the accumulated demand, based on the pipe length, and this is the summary considering all this point. This is the most critical point, this pipe. This is the second most critical point in your network. This is your third most critical point in your network. So you have, based on a particular type, a criticality and the overall the criticality of the pipe that is given here. So 21, 44, 23 and 11. So let's consider this 5 pipe. Pipe number 2140. This 2144. Pipe 21, pipe 4 and pipe 40. Pipe 4 and pipe 40. So if I go to map, so this is your critical pipe, this is your critical pipe, and this is your a critical pipe. The criticality level is different. So overall, let me zoom to this. Just if I can remove this. Yeah, you can see this pipe criticality, it has also come here. So you can also see from here the pipe criticality range for with respect to this final. So if I apply it here, so in Excel also you can do the same thing. It's also uploaded here. It was not uploaded before, but you can see it's clearly uploaded here. You can also classify as per your choice, and then go to map, and you can see the pipe criticality based on the color code. So if I remove other color, then it will be let me remove this. Let me remove this. So you can clearly see which is more critical pipe. So this is the most critical pipe. This is also critical. This is also critical pipe. You can see here, and then this is also critical pipe. So red to orange to green to blue to this. You can also select from here. This so selected. So these are the pipe which are most critical. So let me, if I say map, and then if I say unhighlight all, and then you can see with the color code which is more critical. Based on different consideration, different pipe will be critical. If I say first, if I will take this, then you can see this pipe is your critical point, and this pipe is your critical pipe. Means different level of criticality is there, obviously, but you can see this it's showing is the type 1, the most critical. For this, if I will go on this, and it is also dependent on the pressure that the pressure. So here you see this becomes more critical pipe, and this is your also critical point. So for different consideration, different pipe is more critical, and then it depends on the service pressure that you are using. If you are using this, and then if I will say that at 8 AM, 8 hour, I want to see which is more critical, then obviously at different time the criticality will be different. File is open, I think somewhere. Yeah, this because this is open, so that's why it's saying that your pipe your file is open. So I will close this. Don't save. And then run it again. So the pipe criticality will change now. So if I go to this map, and let's say the same map, if I will plot here, let's say, if you remember from previous, if I remove this, so now you see this becomes more critical. Then second number this, then others. How you are deciding this color code, it all depends on that. So how easy you are able to see in this color code. And if I go to this final criticality, so then this pipe is more critical, and then this pipe is critical. So if you are not able to see, just go here, color classify. Let's say if I say here 30, and here I say 0, and then I say distribute, okay, and then I say apply to map. So anytime you can change the color code if you want to see this map. So you can see, so this pipe is your critical pipe, this pipe is your critical pipe. It depends on, because when you change the demand criteria, the flow pattern changes, and when flow pattern changes, you can always see the flow direction. Oh, sorry that I deleted that file before, so I need to run it from here also. It's not able to find that file. Is this clear till now, everyone? Can you do the same thing, everyone, quickly?
Yes, sir.
Can anyone share their screen just to let me know? Just that I don't have this simulation, I will run it from here also, so that.
Can you see my screen? Mariji?
Yes.
Yes, James.
Yes. I can, yes.
You can see my screen, right?
No, we cannot see your screen.
You want me to share my screen?
I wanted any participant to share their screen.
Okay.
So may I?
Yes, yes.
Yeah, Anil,
Please.
go ahead, Anil.
Yeah. So you can see the means the criticality of the pipe depending on what you have given, and the same result you can see in Excel also. Can you click on this pipe criticality table? So you have given 25 meter and you have done it for 0 hour. Just do the same thing. Just type it here only, say 7 hour, and then run it again. Not from there, here, this run. This run runs the model, and this simulation runs your pipe criticality. So you see here, you see at computing hydraulics is shown. Now click on here, this run. Anil, can you click on this run in the pipe criticality? Yeah. That CSV file is open. You need to close that CSV file. Yeah, so now it has run. Now go back to this map view. And just remove the, yeah, just untick this below options. Okay, and then just okay, also why it's all pipe coming critical? Only one code. So go to this, yeah, can you click on this? Can you give me the access? Just a minute. I'm requesting the access. Okay, and then I go here. Just a minute. Your all pipe is the same critical length. How it can be possible? So for the P1, you can see your criticality. This is the criticality. Different pipes are critical. If I see for P3, so then this becomes more critical, and this becomes I don't know why this is. And this is all pipe is critical in your network. There is some problem in the design. I don't know the criteria that you have given due to that. So let me do one thing is, very quickly what I will do is, I don't want, because I have to work on the pump also. Otherwise, I will remove this and just using ESR. Pump will have different criticality factor, and if you will run it with ESR, it will have different criticality factor. So I will not disturb your model, but I will show it on my system that if you will same criticality you are getting, and then you will convert into from, instead of using this pump, if you will make it ESR flow, so then the criticality level changes. I don't know why you are getting all pipe critical this value. Can you open the Excel, the spreadsheet? Everyone is getting a problem like this?
So when I ran it for 0R, the criticality was different, but for 7R, the total network is in critical state.
All network is getting critical. So yeah, so
can you see my spreadsheet, sir?
No, I cannot see your spreadsheet. Can you? Yes. So all pipe, actually the criticality is in the range of 63, 65, 50. Can you go down? 53. So it's varying, I think. So depending on this, what you need to do is, I can see it's from, I think from 50 to say 70. So what I will go do is, I will go to this layer and symbol. Just okay, just you need to give me the request. And then I go to this layers and symbol, and then I go to this symbology, and I will say classify, and then criticality is very high, say 70%, and the minimum, yeah, you can put minimum 0 also, or if it's never going to 0, then just I will show you first this, and then I will say okay, apply. So you can see different color, but again you can further modify it by giving the range from, let's say, from, instead of giving this 0, let's say if I give 50, if all criticality is more than 50% in that case, so I will give this, and then you will have much more better picture of that. So in this way you can create the pipe criticality information for your catchment. Okay, so this criticality is important criteria when you are doing some maintenance work. So when you are doing some maintenance work, you need to see the pipe that you are replacing, if it's means, with respect to different criteria, how much node you are going to affect, how much demand you are going to affect, or the overall performance of the system you are going to affect when you have some problem in a particular pipe. So normally, if let me give you an example. So is this clear?
Yes, sir.
Okay. So this is the. Can you can unshare your screen? Okay, let me share my screen. Okay. So this is regarding this pipe criticality analysis that we have discussed. Now, very quickly, what I will do is I will show you one more a special analysis, let's say fire flow analysis, and then we will move to this valve component. So this fire flow analysis, again, I will get this fire flow analysis option here. And then same way, I need to add a fire flow, this insert. And then you can use, if you have this hydrant information, then you can use the hydrant data, or you can select any node in this list. Let's say I select this node selection list. Let's say I go to the map, and let me remove this layers result file. And I also remove this for the time being, and this also. Okay, so this is my original layer. And then what I will do is, let's say there is some fire here in this area. So I want to see how much flow or pressure is available at this node for the fire flow analysis, or in this pipe. So I will select this node. Then I will go to this fire flow analysis. I will say use selected junction node. Then I will go here, and then I have here option calculate available flow for design pressure, calculate available flow for design flow, or based on QH curve. So let's say how you decide. Let's say there is a fire at a 2-story building. So you need certain head to douse that fire. So you need certain pressure. You know how much pressure you need. And you want to see how much flow you can get with that pressure. So that means I have, for a given pressure, let's say I need a pressure with 10 meter. I need a pressure of 10 meter at that node. I want to see how much flow is available with that much pressure. And then there are other options like the maintain, you can maintain velocity if you want. If you want to maintain residual pressure, if the pressure goes down, you want a report. So all this you can tick as well. But the simple, let's first go with the simple thing. So I just want to see how much pressure will be available. How much flow will be available with a design pressure of 10. So I put this value, and if you see in the setup, it says a green tick. So only this information is required, and you can run your simulation. Cannot iterate flow for pressure. Node ID 9, fire flow computed, 0, fire engine closed. It's not able to simulate. Let me check. I am running because I am checking it at 0 hour. So obviously 0 hour, there is no flow there. So there is no calculation there. So if I will change this value, or I can either I can make it, let's say 8 hour. No. Okay, so let me go to the simulation specification and let me just let me check here. It should not be a problem. Okay, so if I go to, just let me see how much pressure is there in this node. It should not happen. Everyone is getting this error on their system?
I am also getting, sir.
Same error?
Yes.
Okay, let me see. Just let me see what is the problem. Then I will let you know. Time level 0, static pressure. The static pressure is already below the residual pressure. Okay, just a minute. If I see here, link, and then if I see junction head, map, if I go and if I 17. Dual pressure. This is the simplest way of doing the calculation. Just give me a minute. It's Money. Are you here?
Yes, sir.
Can you share your screen and show them the WaterNet advisor?
Okay. Yeah.
Very quickly. I will just have a look in the meanwhile. Okay.
Yes.
We will be ending in 15-20 minutes. What we will do is means because valve component is valve and water hammer is still pending. So sorry for that, but if anyone is interested in that, we will start our session at 11 a.m. on the Monday, and anyone interested can join for 1 hour. I will explain you this water hammer and this valve thing on Monday at 11 a.m. And today in 10-15 minutes, we will be completing this component. Is it fine with everyone?
Yeah, it is fine, sir. Just one
Yes,
request
sir.
in that scenario, kindly record that also and please share it with us because all of us may not be available.
Yes, sure. I think it's already recording, no?
For the Monday session.
Yes. Yeah, 100%. No problem. So this, except for water hammer, we will be completing all other sessions. Just I will just stop sharing, and Mani, just quickly, can you show this model?
Yes. So you can see my screen, all of you?
Yes, sir.
Yes.
Yeah, so basically this is the WaterNet Advisor is both for collection system and water distribution. It's a cloud application. You can upload your model you have developed in Mic Plus in WaterNet Advisor, and you can use it on laptop, mobile or tab. So basically this application is for the people who are like field engineers, and also for the senior staff if they want to see that what is happening in the network in the office itself. So they can assess the model very easily. So to sign in, to use it, this is the website waternet.dhigroup.com, and you have to have the ID password for it, and I'll just use mine. So this is the graphical user interface of DHI WaterNet Advisor. In this, you can see on the right side models, scenarios, and map. So we are on the map view for now, and in the map view we have layers and various analyses you can do, and all the information in the model. If you have, you can assess that also. So it's basically more of like we use this GIS and all, full extent and all. I won't waste much time on that. So in the left panel, if you see, so these are all the components of your model. So first, background map, you can use two options of OpenStreetMap, and also if you have any base map. So in model, there are various components as we are doing water distribution. So if you have tank, junctions and pipe network, pumps, valves. So this is the network. This is basically one of the example model we have uploaded on WaterNet Advisor. So in this you can see these are the various analysis you can do. As we do this special analysis in Mic Plus, here also you can run the model and get the results quickly at any given place. Yes, you have to have a very good internet connectivity for that. So now coming to how to upload the model, what file exactly you need. So if I go into models, so these are the registered models we have already uploaded on this. So if you want to create a new model, you can create a new model uploading a new model. If you want to edit the existing model, you can edit also. You want to delete, and if you want to add any GIS layer, you can do that. And calibration data for the calibration purpose and validation, you can add calibration data. So if I click on new, so these are the details you have to fill in, the name, the description, and also your basically coordinate system. And then these are the model types. So there are four model types. First is what we are doing, water distribution standard model. And if you have online model with you, you can upload that also. And DHI is your collection system. Again, part of Mike Plus itself, and then collection system built on SWMM engine. So if I click on this, so you have to choose a model file. So it will be, if you have developed any model, you can directly upload it and it will open and reflect here itself in registered models. So for now, we are not creating any new model. So once you click on any registered model, there's a button of activate. So this model will reflect into the map view. For now, we are using this, and this star button is that this model is activated, which we have seen in map view. So various scenarios also you can develop base scenario on different aspects. You can develop various scenarios, and again, if you want to activate the any given scenario, you have to click on activate. You can also copy or make a copy of same scenario, that is cloning. And if you want to create new button is there, and again edit and delete. So I'll go to the map view again. Let's see if I can show you.
Mani, do you have this this model with you that we have generated? What you can do is you can send me, you can share with me the user. Can you send me to user ID password?
Yes.
Okay, just a minute.
Matt, I'll send it on Teams.
Yeah. Also the link.
Yeah.
What I will do is I will upload the same model on the this and I will show you.
Should I unshare?
Yes, please.
Okay. Thank you all.
I will upload this model only directly there, and then I think they will have better idea. Do we have password for them also, Mani, so that they can do hands-on?
On Waternet Advisor? No, sir.
A common which they can use. We had created before.
Maybe if we are keeping this 1 hour or 2 hour session on Monday, we can generate something for them so that they can practice.
Yeah, sure.
Yeah.
So what is my screen shared?
Yes, very much visible, sir.
Okay. So you can see basically you will be given a user ID password. Once you have this user ID password with you, you can log in at this Waternet Advisor, and once you log in, so this is the map of the last model that has been uploaded here. You can see, and if you want to upload a new model, just you need to select your model file, the same model that we have created here on this PC. On desktop, this training mic one on day 2. So I can upload this model here. So you can also upload the .inp file here, or you can or this SQLite model. So any model, and you can give this you can share with actually whether it's personal or if you want to share with all. Or if you want to share only with a particular person, if you will give this name here, then it will be shared only with that. You can give any, just test one, and then this projection is, I don't remember, I think it is 43N. Sorry, not here. Here. I think it's WGS. This marketer, and right, Mani, this is the projection for 43N.
Yes, sir.
Okay, and yes, this is WD online. No, or let's say first keep it a standard only, and select user. DHI, let's say, if I say what more information I need, Mani?
Need to save the model.
So field is
valid input. Maybe you can try with INP. Okay, description you have to give.
So I have saved it. So when I go to this scenario, just a minute, where I go to model, and model registration failed.
So try, can you try with just I'll tell you 32643. Hello. Hello, Nisa, are you there? Am I audible? Okay, he got disconnected maybe. Just wait for few seconds.
Any? Hello,
Yes,
Mani?
yes,
Yeah,
yes.
one query is if you have any doubts or if you're coming across any problems, can we mail you or Manisha so that we get some clarity?
Absolutely, absolutely, at any given time.
Yeah, that would be good.
Yeah, yeah. And this is for everyone. Please make sure while you're practicing, definitely you'll get some of the doubts to be cleared. So please feel free to email me or Manish sir anytime.
We don't have Manisha's email ID. We have yours and James. Okay.
I'll put it in the chat box. Just
Sure, sure.
Hello, sir.
Yes, yes, Prashant.
Sir, what about licensing of the software?
This will work for coming 2 days, and I'll provide you the evaluation license for 1 month, maybe tomorrow or by Monday. I'm in the process to get the license from.
Money.
Yes.
I have extended this license till 30th of July. Okay.
Okay.
Hello.
Yes.
Yeah, we have extended this license till 30th of July. After that, we'll give you the 1 month license.
Very sorry. Actually, I got disconnected in between. So what I was explaining is, you see the error that it was giving here was this coordinate is wrong because we have worked on 43N, and 43N is not this code. You can go to Google and just write UTM-43N, and this UTM-43N code is 32643. So here SRID you need to give is 32643. So let me go again here. And the password was same. Go to model, and then this it has created, but this is not correct. So you can see here, but this has to be 32643. So it has, okay, even though it has given the message, it has automatically created this. No, this is 15th January. No, it's something different. Slow. Okay, so let me create again. Name, test, description. You can write anything. Just this is important. It's 32643. Yeah, UTM-43N, and you can also select this INP file also here on SQLite, and then you can share with anyone which you want. You can see the message, the registering model here. So any name you give, just register your database here. A model has been registered and it has been activated. So it's available on this network. And once it is on the network, I hope Mani has already explained the layers and features here. So what you can do here is you can do all type of analysis directly. You can access the same user ID password. You can connect from a laptop also. Hydraulic, just select this hydraulic here. Once you select the hydraulic, and then you can do this hydraulic analysis as well. So let's do this. One more thing is so this is the run button. So you can analyze directly from here. You can run the hydraulic, whether at whatever interval, whatever you are hydraulic time step, simulation hour. You can run both dynamic and static this flow. And once finished, you can download the result file. You can see the result here also. So if you will like, if I will click on junction, so that means this is selected, and then you can select any feature from here also, or with value also. And you can also first, what you need to do is, first you need to select, like if you want to select junction, and then you go here and select the junction, and you can see the details here. If you will go to this hydraulics, and if you want to see the head, so I will select first this layer, and then I will click any point. Let's say if I click here, or let's say you can see this node ID. Just a minute. And what is the head here with the simulation that you have done, and with any point, if you want to select this detail will come here. If you want to do fire flow analysis, so you can create analysis fire flow, and it's very simple. Like I want a pressure of, let's say, 20 meter somewhere, where, so for all, or for selection from map. So if it is selected, and if you want here, or let's say if you want here, I can say just simple here, say click here. So you will see at a time you can do for 3 map. So this is junction 1. If you want only for junction 1, it's fine. If you also want from here, you can also do it here also. So wherever you want to do this, so I want to, let's say, do this here, I will simply say run. So with 20 meter pressure, how much flow is available? This much flow is available. So you can do this. You can also change it for pressure for flow. Means you know how much flow is required. You want to see how much pressure is there. So let's say if I say 5 liter per second is required. Just assume this. And I want to know how much pressure, with how much pressure I can get this value. I can get 73 meter pressure with 5 liter per second. If I will make 10 liter per second, I can get 65 meter pressure. But if you will increase the flow, the pressure will reduce. So you can do both analysis for means whatever node you will select, it will do the analysis for that. Flow for pressure, pressure for flow. So and you can give any time, date, time, hour for which you want to do this analysis. So this is very easy to do, and in any time you can download the model on your local system also for that particular analysis. So same thing which the fire flow analysis that I have done here. Here also you just need to go to this fire flow analysis, and here I need to select use all junction nodes. If I want to do this calculation for all, and then method maintain residual pressure, just you need to take this, that what is the design pressure and how much pressure you want to maintain. So let's say it's 30 meter, and residual pressure that I want is 25 with this 25 meter. And then if I will run it, it's computing the value, and there are certain nodes where it's too high, and there are certain nodes where it's too low. It's giving me that there, in those cases there is warning, and for other cases it will run the fire means fire flow is 0.4 or it's extremely high, it's giving a message. And then for individual node, I can go to interactive. The same I was clicking here. So select any node and give any pressure, let's say 20 meter, and I want to calculate flow. The flow will be 31 meter, and let's say with 20 meter flow, what will be the residual pressure? This. So either you want to click this, select this, any node you select, just you browse here, just go to, let's say, this node. So what will be the situation at this junction type 39, and then let's say this what will be the pressure? So with to get the flow of 20 meter cube per 20 liter per second, you have a pressure of 35.9. For a pressure of 40 meter, what will be the flow? So this will be the can everyone do this calculation, this fire flow analysis quickly? Have you done, anyone? Anyone here?
Yeah, it's loading, but it's giving me a NAN, no?
Not a number.
Yeah.
So like for some of this, where because of your design, if I will select a particular junction where it's erroneous value, then there will be problem. Otherwise, for other location, like I have shown you, it should give you that level, the level and discharge. Okay, if you want to share your screen, you can share. But before that, let me complete my topic, and then we will see individual queries. So similarly, this fire flow, hydraulics, you have seen, pipe criticality you can do, and similarly one of the option here is water edge. Someone asked about this water quality, and yeah, your duration means to know if it takes lots of time to reach for the water to end, so you need to increase the simulation duration in that case. For our, it's a very small, so it's only 1 day simulation duration. You can say, if you want to save your result or log file, you can take this and then you can run. It's very simple. The simulation has completed, and just you need to go to this here, this if you want to see, let's say, water is below 1 day, 1 day to 2 days, 3 days, 4 days. You can see these details. The color code will be based on that if you will select this option. Maximum link. So you see all this is below 1 day. The color tells you that below all is below 1 day. So this way you can do the water edge analysis. There are lots of analysis. All this analysis you can do, very quickly using this using this WaterNet advisor. Same thing is here also. Just need to tick from this model type, any topic. Cost, for that you need to define the cost, the pumping cost and everything, and then you can do this cost analysis. Shutdown planning, mainly this pump shutdown or valve closing analysis. Water hammer analysis we will be taking in the next session on Monday 11 a.m. I will be taking this water hammer analysis, and water hammer analysis only means it is a part of, we have completed pump but we have not touched the valve. So when I will explain the valve, and then this pump and valve means when you close or open, or pump you start or close, and we will see where means how we can manage this, we can solve this water hammer issue there. So I will also take this topic with the water hammer analysis. Now with this we have completed all the topics. Sorry for getting little delayed. There were some hiccups in between which led to this error, which led to this delay. Anyway, on Monday 11 a.m. everyone is welcome, and we will do this water hammer analysis. Any question till this special analysis that we did today? Yeah, well, one had some question. Just please share your screen and just let me know.
Yeah, sure. Yeah. Yes, I just shared it.
Yes. Here you see, means it depends on this means when you need to define your residual this residual minimum residual. This just take this maintain minimum residual pressure and give this let's say 20 meter, 25 or whatever, means because in our case with this it's already very high.
Okay.
This pressure. So now it will solve, but some of the node will have either as okay, so not a number. Can you go to this general? Okay, so use all junction. Let's select this duration. Let's say it's a 2 hour or 3 hour or 8 hour something, 6 hour, 5 hour, whatever. And okay, then go to method and just click on yes, just click on this run. So many places is not a number, but some places also. So okay, so can you go to this interactive session? Interactive next to run. Yeah, select any junction here. Use this, either this or yeah. Select any junction. Then give some pressure and calculate on flow. So it's calculating flow, but we will have a look why it's not calculating here. Any node select and give any value and then calculate pressure. So wherever you have, this is more important, because wherever you have a flow fire,
okay.
you have two things into consideration. One is, let's say you have a 4 or 5 story building or 2 story. If it's 2 story building, then you will need more flow and less pressure head. So if pressure head is less, so I can give less pressure, and then I will know that how much flow is available with me, and then we can different hose pipe that is fitted that has different flow, means you can maintain the flow in the pipe system which is used to douse the fire, and for that I need to know how much flow is there into the system, and this we can calculate from here quickly from the existing network. At given time, you also give the time, and that time how much flow is there, that we can calculate.
Right.
right? So this is the way you do this fire flow analysis.
Okay.
And can you close this? No, just just yeah. Can you click on the report? Yeah. So static demand, residual pressure. I think I don't know why it's. Okay, some data is missing. Something. We will have a look. Can you go to the map again? And just click, just close this fire flow analysis. Have you created the zone?
Yes.
Okay, so click on the zone, click on the fire flow analysis again. You are search within the, can you tick this, can you browse this, search the
sorry, browse through
this just you see, search with the same zone.
Okay.
So you are searching with the DMA zone. You have given their DMA zone?
No, I gave some numbers. I mean, zone A.
Yeah, it's a DMA zone. You have given DMA zone only. Okay, so it should be DMA zone only. Okay, and simultaneously fire flow. Okay. Can you just select the another method? Let's see with the other method. Yes, pressure for design flow. Okay, and yes, run it again. So it's calculating, pressure is calculating. Only thing with pressure, it's not it's calculating.
Not calculating the flow. Okay.
Yeah.
Probably we'll try now with the DMA zone. Maybe it might work.
Okay, so if you are calculating flow, then you also just take this maintain velocity.
Critical velocity or the maximum velocity?
This maintain maximum velocity. Just take this maintain maximum velocity and give this. Yeah, keep it meter per second. It's fine. And then run it again. Actually, every time they they update, they made minor changes into the model. So.
Okay.
No,
Still it's not completing.
So
but few places it's computing. I could see some 22 point.
Yeah. So anyway, there it could be somewhere it's no flow calculated. Somewhere it's not with all point. Wherever you are, yeah, somewhere it's calculating. I don't know. Means.
Yeah, could be based on the demands and stuffs, right?
Yes. But the whole idea is you can go to this interactive session, and for any node you can calculate.
Right. Okay.
Right?
Okay.
So
okay.
Yeah. So that's what we were doing on the WaterNet Advisor also, right?
Right. Okay. Yeah. That could solve the problem. Okay.
Yeah. So sometimes they do minor changes in the model, and because this is the latest version that you have downloaded _1, and they have done minor changes. I still have not gone through those changes. So maybe they might have changed some way of doing this. So anyway, I hope you have got the idea, right?
Yeah, I got the idea, sir. Okay, no problem.
Yes.
I'll dig in. I will explore.
Okay. So this is means I have tried to cover the maximum topic that you may need in your design work, except for the valve and this surge issue. Okay. Clear? Any more question? Anyone? Puskar, Harshul, Prasant, Rajkumar, Shreya.
No, sir.
Okay,
Yes.
okay.
No, sir, it's clear.
Okay, okay. So we will have one session again on Monday at 11 a.m. Sorry for extending this. We normally do not get this problem, but I don't know. There means few hours has been lost due to this due to some of the technical issues which we were not able to generate in between. So sorry for that. Uh, one more hour I will need on Monday 11 to 12. Thank you everyone.
Thank you so much, sir.
No problem, sir. Thank you so much. Thank you.
Thank you,
Bye
sir.
bye.
Thank you.
Thank you.
Thank you so much, Manish sir. And yes, I'll send you the link for Monday. I'll share the link from 11 to 12. And further, then yes, I've shared the evaluation form with you. Please fill in the details and send it back to me. And also, yes, certificates will be provided to you all on Monday itself. So
Okay, Mani. I mean, I'm not sure whether I will be able to make it for the Monday session because, yeah, we would be working on the day. So please provide us the recorded video for Monday session as well. So it would be very helpful.
and yes, again, I request you all, if you have any issues faced in the future, you can always write back to us, to me or Manish sir or James. And yes, that's it from my side. Thank you so much. It was very good time last 3 days. And thank you, Manish sir. Thank you all.
Thank you, Manish sir. Thank you, Mani. Thank you, James. Thank you for arranging.
Thank you, sir.
Yes.
Thank you, everyone.
Okay, I'll just end this meeting for all.